Sure, sir. I'll just start the recordings. A very warm good morning to our speakers, Sandeep Banerjee, Shimadri Akash from SkyMap Global, Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, Dr. Suraj Kumar Singh, faculty members, students, and all the participants. I welcome you all on behalf of Suresh Kyan Vihar University on the 16th day of 21-day winter school in Geospatial Science and Technology. We are very delighted and eagerly looking forward to have you all involved in this esoteric program. Now, this is with this I would like to take a brief moment to introduce our first speaker, Mr. Sandeep Banerjee. Director Strategy SkyMap Global. He is geospatial business leader with experience in mapping and implementing satellite imagery and geospatial product sales for multiple organizations globally. He has experience in managing complex business use cases in the South Asia and United States. He conceptualized and implemented various GEOAI, remote sensing, location, and geospatial intelligence data analytics products and solutions with a value proposition and very high ROI. On this note, I would like to invite Mr. Sandeep Banerjee for taking forward today's program. Sir, you're most welcome.
Thank you so much, Priyanka, for such a warm greetings, and thank you so much, Dr. Suraj sir, Dr. Shruti ma'am, for inviting us, inviting us for the presentation, and hi everyone. This is Sandeep Banerjee from SkyMap Global. But before I start the presentations and all, I would like to share with you all. Today, my colleague Akash is not joining because he just last night he went to hospital and found COVID positive. So he has some throat infections and all, so he will be unable to join the call. But I'll take it forward the call in more detailed way, based on the need. And I called Akash in the presentation or the demonstration is that because he's from the development side. He's our senior software developer in the architect side. So he can, put more glimpse on the developmental progress. But however, I'll take it forward from here. And maybe in developmental side, having a hands-on alone, we can just do it maybe in other side. So with the permission of Suraj sir and Shruti ma'am, I'll just push start the presentation.
Please.
Okay. So first of all, thank you so much, sir. And I think few of the names are known to me because I think last year we have done one set up an demonstration or just one day webinar on our product Yo Factory, which we launched last year. And so I can see few of the known names and all. And I'll just take it forward from here. But before I do that, I'll say I completed my master's in remote sensing from BIT Misra. And from that onwards, I started working on different applications, orientations and all. And currently I'm working on more into strategy into geospatial and connecting with the real world challenges. And we are currently operational on a few of the countries. So just allow me a moment to share my screen. So can you see my screen? And just
So it
anyone
has
please
not yet
confirm.
come. No, sir.
Okay.
Yes, sir, the screen is visible, sir.
Perfect. Yeah, so you can see the screen, right?
So it's a request, sir. You have to, mute and keep the volume muted of any one of your device, sir.
Hi, Priyanka. Can you hear me?
Yes, sir, I can hear you, sir.
I'm extremely sorry. Can I just share the presentation with you? Can you please share from your side? Because
Sure,
I'm
sir.
traveling now outside India, so there is some restriction in the hotel that doesn't allow to push the screen outside. So
Okay.
I just spoke. So I'm just sharing. I'm just emailing that thing to you. Can you please tell me your email ID?
Yes, sir. So you can send it to Suraj, sir, also, and or you can send it to me on my WhatsApp number, sir.
10
Sir, you
to
can send to Suraj sir mail on the same mail where you get the invitation. We can share from our side.
To the Shruti madam email.
Yes,
Yes,
yeah.
sir.
yes, anyone you can share. We will share from our side.
I'm extremely sorry for that.
No issue, sir.
No issue, sir. No issue.
Yes, shared with Shruti madam.
Just wait, sir, for a second.
Is there a way you can update it so I can share my screen? Can you just open it? I can share my IP here. Okay, no problem, no problem. Please just check it and let me know. Yeah, thanks. Yeah, so so let's just start in a fresh way. So yeah, thank you so much for helping out on that. So today we'll just focus on the presentation or the details about spatial data infrastructure. So that's a very specified topic. Most of you know about government of India, and especially if I talk about India, and some global synonymous now, because everyone wanted to come into a spatial data infrastructure in each and different organization to bring everyone to a single umbrella. Because as we all know, the current government or the or from if you look into the 20 years back, each and individual state government departments or central government department, they work on the silos. So let's say agriculture department build their own data sets. If I go to PWD, they build their own data set. As part of remote sensing application center, they build all different sort of data sets. So there is a vision has been built by the government of India and led by NSDI. It's called National Spatial Data Infrastructure, that bring everyone to a single umbrella and work on a structure of the data, or work on the metadata, work on the cataloging of the data sets, so everyone can have access on their data set, but with certain standards. So slowly they have come up with the standardization with OGC, which most of you know maybe is called Open Geospatial Consortium, to bring a sort of data set, because once we are dealing with large volume of data had to be standardized format. So that's what they bring the OGC services on top of it, and bring an infrastructure. So currently in India, we are doing two state level project. One is Arunachal Pradesh government and one is with the Nagaland government, and we also discuss it with couple of other governments to make the standardization of the data into the state level and connecting to the national level. So that's basically the concept about SDI. I will go very detailed way into how this SDI work, and and what are the more conceptualized format we do in the SDI side. So can I just go to the next slide, please? Yeah, so just go to the next one. Because you all are from the same side on the GIS and geographic information side, so I'll not take much into that, because you all know that how much of data set we build through a different source of information, through a different algorithms, or through a manual processes, or in a time series data that hold by the government. So if I talk about bringing all the data into one umbrella, there is geospatial data infrastructure cookbook. We call it as a cookbook because there is all the standardization has been written, and some of the cookbook also published by the IIT Kanpur and IIT Kharagpur, that they work on a lot of standardization of that. So if you put into that, they told the technology, policies, standards, and human resources necessary to acquire, process, store, distribute, and improve utilization of geospatial data. So if you take this single word, the technology means it doesn't restrict it with the remote sensing and GIS. It can bring up an IT infrastructure, all different sort of technologies together. Policies, because that the different policy makers work in the government to make a policy of the data, because data is not open. Data is not open for anyone, or data is not open to us. Just like in country in India, the data is not open. Data has certain restrictions, data had certain policies. So policymaker defined the policies, that what are the data to be bring it to the public, or what are the data to be restricted within the government. Standards, as we talk about, just like that, if you talk about vector data, we had make certain standard, right? We support on the XML, we support KML, we support SAFE file, we support other sort of data sets. So just like that, to bringing all data into one sector, there is also standardization. As we all know about WMS service, WFS service, WMTS service, WCS service, different kind of REST APIs, because that can bring everything. So there is also a standard. I'll come later into my slides. Human resources to acquire the process, because all data what we are bringing today, it's required human resources. Just like someone doing it from the supervised classification, building some raster data. Someone is extracting from some AI algorithm to bringing some raster or vector data. or someone is doing a digitization to bringing all the data together. So what are the different acquirement processes? It can be high resolution satellite imagery to low resolution satellite imagery to different application. So acquirement of the data and then store. So all the, once you work on the technology, the policy has been made, the data standardization has been made, the data has been acquired. Now you have to store the data, right? That's where the hardware comes in. So all the storing of the data is also have challenge. There is a lot of challenges come on storing of the data, because once you are serving to an 10 to 100 number of departments, the storing of the data is very, very challenging. So that's also come under SDI. And distribute the data. So how you will distribute the data to different organizations? So let's say Suresh Gyan University is the organization who hold the data, host the data. But how they will distribute? Because maybe mining department data, some department wanted to view, but to edit the data is a challenge. So how will distribute them? So building an editor problem, or building a metadata problem, when the data has been built, what the data has been built, and improve utilization of geospatial data. Once we connecting all the dots together, then it's make us very beautifully, better way to utilize or improve the utilization of the geospatial data. So that's in GSDI cookbook. And once you facilitate all the points together, it means we're building an ecosystem. So it's a spatial data infrastructure ecosystem which helping the department to connect them together, bringing together, and serving together. That's the way the better state or the better policy making or better country has been built. So that's the vision of also in India. A lot of department has been already built up the API, SDI through couple of sources. Few of the state has been built, but in 2021 and 2022, that's more focus into the government to connecting more, like northeastern states, where exactly the data are very challenging to get for the central government. So there is a lot of funding has been done. There is a lot of process has been executed. There is a lot of tenders, a lot of project has been executed to connecting everyone to the central government agencies. So that's that's the core strength of the SDI. On my next of the couple of slides, I'll come very detailed way that how it's been built, what has been built. Can you just come to the next slide, please? Yeah, so if you see, so this is basically a very basic, I would say, UML diagram of an SDI, that how normally SDI works. So if you see in the top of it, there are a couple of, we write about end user and solutions, right? And if you see the bottom of the slide, there is a different sort of information that are available here. So let's say if I go to authority A, so it means authority A has been built certain data sets and they are the owner of the data set, because the entire project or entire data has been built by the authority A. There is a, let's say, private companies, company B, they also have certain sort of data sets. Let's say there is a SDFE, it means spatial data framework, that the different sort of framework has been built. As we talk about WMS service, WFS service, different sort of framework. Some are, some are supporting XML, some are supporting KML, different sort of framework has been built. Same goes for company C and authority D. Now, they're holding a lot of data sets, as we talk about. It can be any sort of data. It can be raster, it can be vector, it can be MIS data, it can be other sort of different information. And now, once we are serving it, once we're putting into all the frameworks together, and through internet, I mean, data will be hosted in a single sort of information. It can be cloud, or it can be it can be in local server machines. And we are serving these things to the end user. So end user can be anyone. End user can be even public as well. Because let's say public wanted to find out that where are the bank's location, and maybe these data owned by the, maybe local authorities or the municipalities within the particular municipal areas. So they are serving to the people. So now end user, what they need, that within their periphery or within the 10-kilometer location, I want to know whether the banks are, where exactly are the schools are. And that's the way the services has been built. That's the way the storage capacities has been built. And this solutioning has been built based on the user need. So some user wanted to do certain GIS, analytics. They wanted to perform buffer, they wanted to perform intersect, they wanted to perform linear operation, they wanted to perform, maybe the ETA, the estimated type of arrival kind of thing. So all those end user solution has been built based on the user to user. If I go to mining department, they work on a 3D data because they wanted to do volume estimation. They have a lot of elevation model. They collect a lot of drone data together. So that's a solution oriented, right? But end of the day, all the data structures should be coming on a SDFE in the framework side. So that's a basic, UML. It's a very complicated diagram if you look into very detailed way. But if you look into a very simpler way, the diagram is look like this into SDI. That how we are supporting different sort of data together, different sort of departments together, different sort of solution together. And that's that's the beauty about the SDI. Can you just come to the next slide? And if you know, I mean there is little of points, we wanted to tell you. Few of the points is very known to you everyone because you are having a lot of data's, operational openness in India. So if you see that, why exactly the SDI had need? If you try to, there is a lot of list, there is almost 13 pages lists of their why it's bid. But if you summarize everything and come up with the basic points, it's saying that reduce duplication of efforts among governments. You all know that different sort of data has been built by different departments. PWD may be building the road data, and the municipality is also building the entire municipality area. Their road data is common. So it means there is a duplication of data. Each department is bringing the data, procuring the data, or they are just generating the data, but there should not be any duplication. So SDI can bring everyone into the same platform, and they can merge the these road belong to the same area. So there will be no duplication of the data. So the department will need that what are the data has been built, what are the data not has been built. Lower cost related to geographic information while making geographic data more accessible. Once we are connecting different sort of data, different sort of department together, then we can reduce our cost from the data generation. It means one data is owned by someone. We can talk with them, we can buy the data from them, or we can come up with certain strategy with them that they should share the data. So I can save the, the ROI processes. Increase the benefit of using available spatial data. I mean, you will be shocked by knowing this. India, different state or central government agencies hold a large amount of data, and we are very data rich. Just like if you look into ISRO, if you look into Survey of India, they are national level. You look into NIC, they are national level people in the national level organization. They build the entire India data set. The same data set also built by the remote sensing center. And if you come down to another hierarchy of the system, the same data has been built by different departments, and then come into the same data has been built by the different districts. So we are very data rich. I would say data rich country. So it can increase the efficiency of the data once we are bringing this SDI together, because there will be data, all the data sort of comes in. And then next level, if you look into that, establish a key partnership between state, countries, cities, academia, and private sector. Because once you are having different sort of data, you can sell this information to the private sector as well. Because nowadays, you all know, or you might be shocked by knowing this, each and individual decision making has been taken place in the corporate or big corporate. It's through geospatial data. Even someone wanted to invest $100 million to building a factory, they do the entire analytics on geospatial data. Where exactly the roads are, where exactly is the agriculture plot in agriculture plot, then in next 20 years, what are the production line happening? So they're submitting all those reports to the authority to taking permission. So once the data has been built, it can support a different sort of organizations as well. There is a lot of openness to the academia and and private sector or academia and state level collaboration to coming up with the research and building a next model using those data. So these are basic 4 points that I wanted to highlight that's needed for the spatial data infrastructure. Can you come to the next one? Yeah, thanks. Now how does I will say how does it mean in practice? Those are very terminological things, right? That building a different sort of data, building an information together, but how it's helping to building a practices. As we talked about earlier, define standards. It means it mandate on federal agencies and encouraged for others. So it means in a short time, it's minimizing the inconsistency. I already explained the processes, what you do here. Next part is the clearinghouse. Metadata description of existing data and advertising what is available. It's very interesting, it's very interesting things and very interesting to know that. Let's say I have a location of, I'll say that this is my ATM location, and that has been, this ATM location has been taken in 2010, 7th of March. The data has been taken. It means the metadata of that particular location is latitude, longitude, when the data has been taken, which bank ATM it is, when it is open, when it is closed. So these are all metadata, right? Now, once we're building on the data standardization, and once we're building all the data standardization, and we are sharing the data, to different organizations, and let's say this ATM had changed from HDFC Bank to SBI Bank. So, this information can be changed into the metadata, and this metadata can be followed in a certain time, that which person, which department had changed this information. Then in a later term, you might all knowing the terminologies or the things is going on blockchain. Then blockchain comes into place. So this is the beauty about the metadata. Metadata is very, very important to understand about any sort of information, that when the data has been built, what the data has been built, who the data has been built, and when the data has been shared, who is the organization owning the data. So this is the metadata information. Fourth point is coming into the National Geospatial Data Framework. So what framework we're talking about, just to discuss, right, how the framework has been built. So a common template on which to assemble other data. Common template. We do a template, right? Just like whatever presentation I'm giving, it's my company template. Because whenever we give any presentation to any organization, be it some corporate or be it some government agency or be it some academia, we follow a standardization, because that has been built by our company, that this is the template has to be followed for giving a presentation. The same thing, once the data has been compiled, the data has been come, so the authorities can take a decision and can bring a simple template, that this is the template has to be processed to assemble any sort of other data sets. And that is the practices has been built. And personally, I work with a lot of organization, and I can see that's bringing a lot of doors. For academia people, this also creating a lot of jobs, because creating a template and following the template also required required resources who know this technology, who needs technology to better way execution. So that those are the practices has been already built, and practices has been also, few of the practices has been changing on a timeline, because once this technology developed, AI comes in, blockchain comes in, different sort of data formats comes in. So this has been slowly changing. It's not static, but it's changing. I'll tell you about the GIS, because SDI is a component. There is a small portal that we made to give a presentation to you all, but unfortunately I'm unable to share my screen, but I'll just explain to you. So SDI, if you look into a particular SDI any portal, maybe after the presentation or after this call, you can all search about SDI. You'll find out a lot of SDI. You can go to United States, you can go to Singapore, you can go to India, even a lot of state, you will find out a lot of SDI portals are available. If you see, the basic component of all the SDI, geodata, metadata, framework, clearinghouse, standard, partnerships. These are very basic parameters, because just spatial data infrastructures all are connecting to location, all are connecting to GIS data. Metadata, we talk about that, that particular location belong to which organization, which department, it's a metadata. Framework, they talk about the different sort of framework has been built, and later on my slide I have more detailed framework discussions. Clearing house, because you need a lot of dumb data has been coming, how you're clearing the data, by special joining, by other processes and all. Standardization, that's I talked about already, and bringing partnership, because once you're bringing a lot of data, you need a lot of researchers, you need a lot of research to building a new level of application on top of it. Let's say I have a watershed data, I have a land use land cover data, or let's say I have other sort of data, like when the new river has been moved, or the new river has been planned, or new dam has been coming up. So bringing all sort of data, we also required in a model, we required in spatial analysis to find out the next level, right? That where exactly are the location for building a new cement factory. So those are the models can we bring up through the partnership model, because it's not single application, there is a large volume of application can be built. So that's basically focus on the partnerships. Can I go to the next one? Yeah. Now, the data provider score. So who are the data providers coming, right? As you talk about geospatial data. Can you come to the next? So now what exactly the geospatial or geographic data is? You all know, I no need to explain on the things. So where exactly the data? It's a community developed data sets. Lot of the data has been come with the cloud sourcing data. You all know, when you are using Google Maps, maybe once you are entering into a hotel, Google will ask you, how's the hotel, send in photo. So that's built by the community, because Google has built their own community to doing a crowdsourcing of the data. Government also coming up with that. If you see, Survey of India also launched an application with them. It's called Sahyog, where exactly everyone, each and individual citizen can contribute some data that surrounding my location, where exactly are the kirana shops, where exactly are the hospitals, where exactly are the clinics. So that has been built by the community. Single purpose. Each department is building the data set for single purpose, because they wanted to make it the smarter and better way to manage their organization. It's a single purpose data set. Potential reuse. Each department share the data to other department to reuse of data. There is a lot of restrictions here, but they do reuse of the data. Road data can be shared to road data. The road department can share the road data to highway department. Highway can share the highway department to railway data. So there is a reuse of data, right? Because once they do all the planning, they do the reuse of the data. Common content specification. So this is, I would say, common. There is no common content. There is a different content for different applications. So there is a common content, means building a different sort of data in a single content places. So sometimes it's not follow the common content, but yeah, we call it as a common content specification, because everyone is following a certain standardization of the data and framework of the data. Can you go to the next one? Now, how you're describing your data, right? As we talk about, we've given certain things, but we'll go more detail now. Now, how you're describing your data. Let's say I am Sandeep Banerjee. I build a data set from my own location. Let's say I build my own college data, that where exactly the college roads are, where exactly the college canteen locations are, where exactly the parks are, where exactly we play cricket or football. So I build a data sets, and that's entirely a GIS data set. Now all the metadata, as we talk about, this is the football ground, and this football ground, which date satellite imagery or ground survey you have done to check the data, who the person is taking the data, what is the area of that particular location. So these are all coming into a metadata system. All nodes are connecting to each other. That's describing your data, that you are the person build the data, and these are the all metadata information has been come into the information. Next one. Now, if you come into the metadata on very detail, we put it as a standardized data element that describe your data. We already discussed about that. Content of the data, why you have built this data. You have built this data to make it more useful of the data, because maybe once you publish this data into an open domain, other professors or other teachers or other student can be benefited from that. So the content is to making an usability of the data, right? Making a location intelligence, making a location more usefulness. Quality of the data, how accurate your data are. If I talk about the school location, what the accuracy of that? If I take the particular location, can I reach to the location, or there will be shifting of 20 to 30 meters? So what is your quality of the data? What condition your data are? What resolution data has been built? Because we talk about different scaling of the data, right? This resolution bit, let's say you're building within drone data, then what resolution, from which resolution the data has been built? If you're building from satellite, then what resolution of data has been built? Next one is scale of the data. What scale you make it? 1:5,000, 1:10,000, 1:50,000. Time of collection, when the data has been built. Drone has been flied on 25th of December, 25th of January 2022. So that's a time of collection. Now later on, if I wanted to change another sort of data I collected on, let's say 15th August in 2022, and certain changes I have done that. So that's also a collection of the data. Areas of coverage, how big are the area of coverage that we're bringing? And ownership and other characteristics of actual data. Who is the owner? Who is the other person of the characteristics in the data sets? Can you come to the next one? The no, I'm come to the next, because these are the all inventory we discussed about. Can you read the next? Now we come into a framework, right? Now we are going in very detailed one. So geospatial data we discussed about. We discussed about metadata. Now the SDI main component is coming into a framework system. So what exactly the framework are? Can you come to the next one? So what basically the framework is? The framework is a very generalized word, right? We put everything on a framework. We called it as a, let's say we wanted to do some analytics, we call it as a Python as a, language, and Python have a different sort of framework data sets. So what is framework? So mechanism for identifying and describing the data using features, attribute and attribute values. That's actually the framework is. Mechanism for updating the data periodically without complete recollection. Because the framework has been built, right? I no need to do A to Z. Maybe A to A, B, C, D is okay. I wanted to change from the E to Z, then I will change only the E to Z because the framework has been built there. Interaction among organization for data collection and sharing, because you are already in being an interactive platforms where the different organization can understand the data collection and sharing processes, the sharing with standardization processes. So exactly, this is a real diagram about that, because we build this diagram and we taken from different cookbooks on while we're doing a project with different organization. We find out that this is very basic diagram to understand the framework. Can you take the first one in the left side? We called it spatial analysis. You all know about this spatial analysis. What basically are the spatial analysis are? Then base of other data, and then finished map. So now if you go to the top one, can you see that what the framework is coming? We called it elevation and bathymetry. Elevation is by there, bathymetry is underground water level, because there is certain application we do also in the to demarcate from the blue band, because blue band observe more into the water to doing in bathymetry. Now how this data has been used? Used for hydrography, you all know, watershed, river delineation, making a microshed waters level planning, making micro irrigation planning, all are doing on hydrography level. Cadastral data, because once you having a hydrography data, you put the cadastral data. Who are the farmer locally there? How much is the farmer land? What kind of crop has been built? Because those are coming into all cadastral data information. Now I put a location data, where exactly the roads are, right? So that's my all GIS data, right? And now if you click into the right side of that, geodetic. So there is a lot of geological data that are available nowadays, or different department build the geodetic data sets. Where exactly the rails and roads, where exactly the boundaries. So all data, if you put it on a summarized manner, so all are bringing in, all are together bringing in, I would say, a framework of the data, because all are geospatial data, all are different sort of data that has been used. And now we all do certain analytics. Earlier we used to do overlay analysis, weightage of overlay analysis, and then finding out a different sort. But due to now, the accessibility of the cloud infrastructure or the technology advancement, like the artificial intelligence and all, people are using more AI model to extract the information. So the entire things is I would say this is an entire framework of the data. And now final things what we are getting from the data sets are based on my need. Now I am in hydrology department. I doesn't want to bother about geodetic or where the roads are or something, XYZ. I wanted to do the spatial analysis. I wanted to find out minor irrigation I wanted to build, so I ended up building the micro watershed and all. Let's say I am the organization of the forest department. I wanted to do the forest boundary understanding of the location, or I wanted to do an let's say wildlife sanctuaries, where exactly the road has to be built without affecting the climate. So I'll do certain analysis based on that. I'm an organization who wanted to know only about cities, that what the cities are. So I look into the finished maps. So this is the entire framework of the SDI. You have a different sort of department, have a different sort of data. They will put into a bucket. Simply they'll put into a bucket, and the bucket will serve them whatever need by the different department. Special analysis need, so they can do a certain special analysis. Someone need only the data to overlay and find out the changes. Okay. Someone wanted to bring in a report and show it to their boss. Okay. So that's the way the entire framework has been built. Can you go to the next one? Now we come into the next one is the clearing house. We discussed earlier, right, that how this clearing processes has been built. Yeah, please next. So clearinghouse, the basic concept or the basic things of the clearinghouse to bringing into the SDI is that discovery of spatial data, distributed search worldwide, uniform interface for spatial data searches, advertising for your data holdings. So these are the basic parameters of the clearinghouse that we taken into consideration for building any particular SDI. There should be very simpler way to discover the different sort of spatial data. I should be able to distribute the different search, because I can search by road, so road data should be comes in. If I search about the municipal road should be comes in. Uniform interface for spatial data searches, there should be a spatial uniform based. If I called A, so head A should be highlighted into that. Advertising of your data holdings. So who are the data owner, who are the data dates, who are the metadata has been built. As we talked about earlier, all the parameters should be simply identified by the clearing houses. Can you go to the next, please? And now we're coming into standardization. Because, as we earlier talked about, all are related to that only. We're going it more elaborative way. Now, can you come to the next, standards? We talk about standards, right? We know all have different companies coming into CMMI level standard. You all know about. Someone is taking a project management, the Sigma 6, so they are standard. Because Sigma 6 is putting into certain standard that they qualified the standard. It means the project management of the Sigma 6 guy is better than Sigma 2. The same concept. Or I qualified for 10th or qualified for 12th. So 12 will be no better than 10th because they have already also studied 11th and 12th paper. So that's all standard. So same thing. Here is also a lot of standard already placed. I talk about field standard, but SIP department need that ISO standard. So ISO is giving a different sort of standard. It's a network security. Now we come into a more broader into IT sector now, because the IT things come up is that once you having a lot of data can be hacked, right? So you have to building a security purpose. What is the security of the database has been built? What are the securities has been built to throw the data into into a global phenomena or in the cloud or in a local infrastructure? So different sort of ISO standard is there. You can find out different sort of ISO even by searching on internet. FGDG standard, working people in partnership. There is also a standard for that. I'm not quite masters on FGDC things because my colleague Akash who work on that part on a developmental progress, he would be giving a more idea, but unfortunately he got affected. So I'll not able to highlight more into that. But maybe later on, any day, based on the understanding, we can set up another session for that where exactly go through the each individual coding purposes. Then there is a OGC we talk about, and OGC is very well known to all. You can come into the OGC things. You can be a member of the OGC as well, to discuss and understand about what are the new standard has been coming, how this standard has been processed, what are the standard you have to compile with, because they are the organization who provide the compilation of the data. The fourth one is that consent organizations. As we talk about, different organizations have different standards. Producers and users of geospatial data. So who are the producer and who are the user of this geospatial data? So these are the standardization that also has been built, and there is a changes on certain standard whenever the better things comes up. Can we go to the next one? Data content, we talk about common classification, we talk about common collection of criteria, what are the criteria, what are the classification has been built. Data management, we talk about metadata, we talk about spatial data transfer standards, we talk about data transfer protocols, because once you talk about any kind of services, you have to know that there is certain protocols are there, that how the data should be standardization. Data should be standardization in the format of WMS. We call it OMF services, right? To throw out our raster data to someone, that I wanted to share some data with you, rather than I'm uploading the data into some things or sending the data through emails or some hard disks and all. Rather than if you wanted to do only the visualization, I will publish area into WMS and then push the data together. WFS services, feature services, where exactly you can do a lot of editing on the data. If I give a polygon of baked data to you, you'll be able to do the modification. That's also WFS. WCS, coverage services. because you can bring all the cataloging services in coverage connecting. WMTS, the tile services, because once you are building a lot of data together, let's say entire country, India is such a big country that if you're sharing a WMS service to any particular person, organization, it's taken a very long time. You require a very good bandwidth. You require a very good internet. You require very good, hardware specification to get the data comes in. But WMTS can serve you based on the tile. I want only to see the Jaipur, so Jaipur data can be built on a tile service and pass into you. So that can be a faster mode for data data streaming processes. Data transfer standards, we talk about different sort of transfers we can do. Clearing and cataloging and standards, these are the very details. Data model, data structure format, query language. So these are the part of it, but these are more into more into development segment. I cannot, I don't have that things that I can highlight more in way. And meaning of terms of metadata, meaning of value of the data, that's a semantic. Metadata, different standardization of the meta, talk about ISO, FGDC. Different terms that we used, different terms that we use for metadata, seabed versus seafloor, coastline versus shoreline. These are normally, it means same, but it means something else. So these are also the part of, clearing and cataloging services. Next, please. We just already discussed about the OGC, services specification that we talk about, interface allowing requests for geographic resources across the, web using platform independent calls. OGC services like, we talk about CSW or coverage services or cataloging services or web map services or feature services. Can you go to the next, please? Partnership, again, all the data to comes in together to building up a new application. That's the way required a partnership model. And few organizations already having a partner with NSDI or building a geodetic data. IT Kanpur is the sort authority who is working with Government of India to building a different sort of partnerships and all. Next. As I talked about, already highlighted those things. The partnership can be built using those data as a federal government agencies, state government, local government, private sector. That we are doing a lot of work with the private sectors to support and PPP mode with the government to building a different sort of application, different sort of information together. Or not for profit organization. So what are the like FPOs? There are a lot of FPOs. There are a lot of NGOs who are also supporting a lot of data and building to the next one. Citizens also part of the partnership, because citizen can also give a crowd source of data sets or using those data and bringing up something else. So that's also a partnership modes are going on. Next, please. So now this is I just wanted to highlight is that allow me a moment, because yes. So so this is the this is the geospatial special data infrastructure, because this is entirely global. It's not related to any particular countries, because in India normally it's held by NSDI. You can find out on the website for that, and they support the state government agencies. Maybe different. It's a Department of Science and Technology, a Department of IT, or Remote Sensing Application Center, or any other department to build that particular special infrastructure for that. But this is the global one. When exactly it has been built? So GSDI association was formed in 2004. The more focus the GSDI has been formed for academic and research institution, government agencies, commercial geometric firms, national and regional GIS associations, and individuals around the world. India is also one of the part of it in a global level to represent. So this is the vision has been built by GSDI, and purpose is to promote international cooperation and collaboration in support of local, national, and international spatial data infrastructure research and implementation. So maybe once we are doing and centralized or digitize our country data, that can be a data processing standard between each and individual country, that they can share on certain data through a certain standard JSON, but that can be only taken place once we are bringing up the standardization on a global level. So there is also global agencies who look after the different sort of things. standardizations and all. So I'll say some of the published, that we've done by, as I talk about NSDI, National Special Data Infrastructure, looked after by India. The United Nations, there is also even SDI, that is the United Nations Special Data Infrastructure. The United States, which is US National Special Data Infrastructure. Europe, the European, Inspire Initiative, and others. If you look into other, North America, South American countries or African countries, they're also having certain standard into that. Just like Singapore has already built up their land record management system, that's also a part of SDI. Because they follow all the protocol, they follow all our networks and all. These are some of the agencies who publish the SDI, taking up the next level. So this is very, this is very interesting, and I wanted to highlight to the professors and to the students also. There are a lot of focus has been built by the government agencies, or there is asked by the different agencies to implement open source information. There are a lot of COTS products are available in the market to make it more useful of the data rather than doing things. But there are also a lot of limitation in the COTS products. You all know, because if you want to do certain customization, maybe you're not holding the source code of the information. So the government has put down for the open source, and we are doing quite things on open source. I'll be happy to, if any student after the calls wanted to do certain things, the understanding about more into open source software, do not hesitate to contact. Maybe you can take our contact from sirs and madam to, so I can connect with my developer team, what they're doing, what are the technology they're adopting, and we'll be happy to help you to bring you more knowledgeable. So Geo Node, you might be all heard about. Geo Node has been built to looking after the SDI framework. If you install the Geo Node, you will be getting all the SDI framework that we talk about. You'll be getting all the different sort of services that SDI need. You'll be getting different standardization that SDI need. So the framework, the entire framework has available through libraries. It's an SDK you can install in your laptop and you can do the customization. That's what we are doing. It's a web-based application and platform for developing geospatial information data and deploying spatial data infrastructure. You can search everyone into the internet, you will get that. And others are Geo Orchestra, Geo Network, OpenSDI, EasySDI. These are all available through open source libraries, open source SDKs, open source platforms that are available. And you can play around it. You don't need a single line of code to do that. You can install it and then you can upload your own data. You can see a different sort of standardization. You can you can share the data. You can restrict the data. You can bring a different username, giving a different role and responsibilities. But yeah, once you're building an SDI, you need to do a lot of customization from this libraries. A lot of customizations are required. So these are very basic SDI softwares I'll talk about. Can you come to the next? So I'll not take this one, because this one you can find out entire things on internet. Nothing is nothing is new in that. Geo Node, you will get it. Most of you are already working on maybe few of the other geospatial like Postgres, PostGIS to hosting the data or saving the data, and then you are using GeoServer to publish the data sets. But those are basically building an OFGIS kind of things. But if you are talking about SDI, that's required all the processes that we discussed earlier. That's why the Geo Node is the best one to do that. We work on Geo Node. Next one. Yeah, so you have to get the what exactly the Geo Node bring the capabilities to the user. Why Geo Node is required to supplement the browse, search for geospatial data and web services. That's already has been built. Upload, manage and share the geospatial data. That's also available there. Create and share the interactive maps. You can create an interactive map and you can share through some services or share through a link to someone. Collaborate and interact with other users. There is a function that you can bring a different sort of hierarchy within the system to collaborate and talk with different sort of users. So already the Geo Node have all the libraries available. Can you come to the next? So if some of you are developer or interested on a geospatial development, I'll talk about the Geo Node, Geo Node tech stack. I mean, tech stack means what are the technical stacks are available or technical support by Geo Node. So it's developed with Django. Some of you know which are working on a Python. You know that Django is one of the frameworks. So an open source Python framework is Django. So the entire front end has been built on Django. It's a Twitter bootstrap for UI styling. So whatever the user interface styling you need to know, you need to do it on a Twitter bootstrap. GeoServer, you all know about GeoServer. Somewhere you use GeoServer for that. So map publishing services used by GeoServer. PostgreSQL, PostGIS are the database used. Even if you have some other database, you can also connect. There's openness is there. Built on stable, mature, open source geospatial projects. API, there's a lot of REST APIs or different sort of APIs are available for customizations and collections. And seamless integration with third-party, Django apps. Because if you, let's say, if you build certain model that can find out the automated extraction of the building, so you can directly seamlessly integrate through Django. So this is the technical stakes are there. Anyhow, I've already shared this presentation to Madam. If you wanted to take some of the content from the presentation, you can just take it from Madam. Can I come to the next one, please? This is basically the Geo Node architecture. The earlier architecture you talk about, that's an SDI architecture. That's an SDI UML. But this is Geo Node architecture. That how the Geo Node things work. So you can see these are all web application with the Django, web cache services, GeoServer, PostgreSQL or PostGIS for the vector data sets. For raster data sets, there is a different file systems for GeoServer. So we are hosting sort of data into GeoServer, and then there is a Geo network is available, which create the Pi6 to support the CSW services, and then it's bringing to your browser and desktop GIS. There is browser means somewhere something is not compatible with different sort of browsers, so you can support there, and desktop GIS, because if you are building some, let's say, some desktop based application or something, so that can be also pushed. You can connect it. So this is the very basic architecture. There is more detail. There is more. Once you go into that, you can find out there is more detail to do that. Can you go to the next, please? So I thought to do a demo because we already prepared some demo sets for you, and this is how the Geo Node look like. There is a lot of customizations we have done, but normally the structures look like this. Different sort of layers, you'll be able to see that. Different sort of maps, you can see that. You can see different users. You can also publish documents, because maybe you wanted to bring some, let's say, hands-on to someone, to your to your publishing a documents to post. So you can post a document, certain documents to someone. So this is the entirely architecture plan of the SDI, and I think that would be my last slide. So if anyone have any questions, can ask me, and then I'll share the link to Madam again for showing the link on the presentation, so Madam can share from their side and I can explain it. So if anyone have any question, please just ask me. Madam, any questions?
Yes, sir. All the participants, do you have any questions, any queries? Please, it is open for you to ask questions.
Or you may write in the comment box.
Yes, any questions, participants?
Yes, thank you for nice presentation. Sir, I want to ask that can this SDI be used for air pollution monitoring and measurement for research purpose?
Yes, absolutely. Because as we talk about different sort of data standardization already there. So let's say if we talk about air pollution, maybe you talk about certain standard of data, right? Maybe some, I'm not quite sure, but some maybe carbon dioxide data, or maybe whatever LST information you are getting for different sort of, let's say, from MODIS or some other satellites and all. Of course, you can follow the standardization of the data, and you can push all the data into the Geo Node to bring a data, as I talk about data cataloging. And you can also put the data metadata information, that what the data, what the unit, what are the details, and then you can build your own model. Because couple of models are available in internet, and couple of models are we build personally into that. So if you are a user of eofactory.ai that you given the last presentation, you can find out couple of models are available that you build it. So you no need to do a single level of code. You just directly use the model and can be pushed.
Okay. Thank you. So one more question, like if I want to make a site for my local meteorological display, so in
Mhm.
my local area, how is the temperature, pressure, rainfall, so that can be built also.
Absolutely, absolutely, because here is not restricted with any sort of data or standard or formats. So you can make it local or you can make it global. It's all about the configuration of the system can supports everything, but what exactly you are building, that's the I would say the USP.
Thank you so much.
Yes, anyone else have any questions? Anyone else?
Madam, Shruti madam, I just sent you an email where we prepared in a small demo for everyone. I thought to share from my side. So if you can share, madam.
So we'll get it downloaded and we'll share it, sir.
It's a link. I mean, it's a link. It's an
Okay,
hosted in the server. So no need to download. You can just click on the link. It will redirect to the page.
okay, okay. So we'll just check.
So yeah. So everyone, this is the um, normal infrastructure of the SPI. Normal infrastructure of Geo Node that we just make the for the presentation, and this is entirely open source. You can do all the changes whatever it required, and in top of it you will be able to see that data, maps, apps, and about. So data means you can, ma'am, can you just click on the data? Yes, please. So you did, data, you can find out different layers as you talk about different remote services. You can build different remote. So you wanted to share some services to someone, you can build the services. If you go to maps, you can see a lot of open source maps that's available. You can go to apps. If you just go to apps, you can explore different sort of apps. All are what is available there. You can find out, we have built something small for Nagaland sample, because what happened, the different sort of data we built up and services for them, and we are just sharing to someone. Then you can see it in about people, groups, categories, announcement, invite user, add user. So these are all part of user management, because when you are going to any services, when you are going to any softwares, you need to do an user management particularly. So all the user managements are also available there. Ma'am, can you go to the first page, please? You can click on the GIS management system. It will take you to the first page. Yeah, and can you come down a little? Do the accept this message, because some cookies has to be accept. No, below. You can see website. Yeah, and you can see there is a different sort of layers has been published. But yeah, these all layers are published by drag and drop. No coding we have done yet, because customization things we put up for coding. If you can see here, there is 23 layers. So if you can click on the layers, you can see different layers that has been published, and all have been updated with the health boundaries, school data, waterways, what the water locations and all. And throughout, and throughout that, what we do is that finally what the department needed, because if department need to build some model that where exactly are the water bodies location, and they wanted to find out that building a new water bodies, so we do certain calculation on the settlements and all that. We do it from the very long time, you know that. And you can see in the right side there is a different categories, there's a different responsibility, different groups. In top of it you can see upload layers. You can upload your own layers. You know, you can upload and you can publish your own layers. Because it is not available for public domain, so that's why certain functionality is not available. But in our systems, its entire functionalities are available. Responsibilities, categories, groups. So this is you know, this is basically a basic SDI, I would say. There is not much detailed. You will get watch detailed application orientation, but this is a very basic SDI, I would say. That you are storing the data, you are building the cataloging, you're building the metadata. You are building different sort of data into one place, so you'll be able to do that. You know, you can add layer, or once you go into the login into the dataset system, they'll be able to see all the metadata. They'll be able to see all the cataloging services that you are building. So you know, so you can just play around. This is we just created for you, so you can play around it. You know, if you're not installing into that, we just hosted some information for you, so you can play around the places. Yeah. Yes, ma'am.
Okay, so the demonstration is over, sir.
Yes, I'll just over to everyone that if everyone have any questions, or what we will do that in the next thing, because we had a plan that we will do certain we'll do certain hands-on on the coding side, but due to that my colleague.
Hello, sir.
Yes.
Sir, this data for only Nagaland. Can we
Yes.
have for another location also?
You can upload your own data. This is just from open source. You can go to DeviceGIS, or you can download from open source data from any particular location. Then you can create an own data set. It's just created for demonstration.
Okay, sir. Okay, thank you, sir.
Or if you have any data that you are working in your research, or in your I would say in your in your projects or something like that, you can play with all the raster data and vector both.
Okay, sir. Thank you, sir.
Thank you. I mean, yes, ma'am. We will. I mean, we'll just happy to be do it another day. I'll talk with Suresh sir for that. Do it another day with a certain hands-on on the technology side, on the technological stake into the codings and all. And we will just take it forward from that. And in between, if anyone have any question, anyone wanted to talk to our team to know about more things and all, we'll be happy to connect with student and doing that.
Okay, anyone else has any queries regarding whatever has been demonstrated here? You can ask. You are open here. So it was a very elaborately described. I guess it was self-explanatory to this participants here itself, that how data can be used and uploaded. Even like we can create our own domain here. Thank you, sir. And anyone else any queries? And shall we move forward?
Sandeep, Varun this side.
Yes, Barun sir.
How are you? कैसे?
Good, very good, sir. How are you, sir?
बहुत बढ़िया. It was very informative, Sandeep. Lecture was very informative about the spatial data infrastructure.
Thank you so much, sir.
So, just I want to know that the kind of data sets what we are using for spatial data infrastructure.
Sure.
Okay. So, when we have the output as a map or JPG.
Sir.
Okay. So, spatial data infrastructure can also include the other formats, or only we can just deal with the raster and vector data sets?
No, it can be other data set as well, sir.
Okay, suppose if we are having other data sets in point data, So the point data sets or some discrete data sets can also be used?
Absolutely so. Absolutely. So let's say, as an example, so let's say you have a 10-point location.
Okay.
And let's say these 10-point locations that belong to something. Maybe 10-point location are all are Kirana shops. Now you have another sort of MIS data or an Excel file which tell that who is the owner and all. So all those data set can be supported and can be doing a special joining.
Okay. Okay.
So it's what happened. The system giving you preferences that you can play around with the data sets, and then you can build your own model for that.
Okay. Okay. So just if the data set is in the point format, or if we are using point data sets, and if it doesn't having any spatial information, so how we can use suppose means what the procedure to provide it the coordinates or referencing system?
Okay, I got it, sir. So normally, if that particular system doesn't have any location, or the data doesn't have any location, that data cannot be represented in a map categories, right, sir? I mean,
Yeah,
I cannot create in a map category. So data can be stored as a documents in the same system, but
Okay.
it cannot be published as a map or published as any service.
Okay.
So it has to be coming up with certain location services on top of it.
Okay. 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 Thanks, Sandeep. Thank you very much.
No problem, sir. No problem, sir.
Any other question from anyone? Any other student or any participant who would like to ask some question related to spatial data infrastructure? So they can ask.
Okay, thank you, sir. Anyone else, any queries, or shall we move forward with the event? Hello? Okay, so now I call upon Dr. Pranay Diwate to take forward today's event. Sir?
Yes. Am I audible?
Yes, sir.
Just a minute. I will share my slide. Is my slide is visible?
Yes.
Okay. Very good morning to one and all. This is Dr. Pranay Diwate, working as assistant professor in Center for Climate Change and Water Research. Today, I am going to talk on some different topic than what you have been heard from the last 14-15 days. My topic for today is the climate change. Then what kind of study will be doing in to know the past, present, and how we can predict the futuristic trend. So my content for my talk will be the present climatic scenario, what kind of climatic changes has been occurred, and how we can reconstruct the past using various techniques. So I'm starting with the basics of the climatology. Now, what is the weather? When we are talking about the weather is nothing but the atmospheric condition which occur locally over the short period of time. So it can be from minute to hours or day. The familiar example of the weather, it will be a rain for a day, snow, cloud, wind, or whatever the phenomena which occur daily or on a basis of what we can say the for a week and all. So sometimes the peoples or the majority of the peoples have been just not able to differentiate between weather and climate. We are using the term climate very oftenly about that. If there is a changes in a day temperature or a temperature of a week, we can say that there is a climate change. So climate is referred to a long term changes in a weather. So the whatever the changes in a temperature, or what we can say the humidity, or whatever the parameter or climatic parameter we are referring, that should be a more than 30 years. That is what we are defining the climate. So what is the different kind of parameter we are taking in the climate? That may be a temperature, humidity, atmospheric pressure, wind, and precipitation. That is the sum of the parameter we are taking in a climate. So climatic changes is referred as the significant shift from the longer term average in a weather condition for a particular place or region. So that is the definition of climate change. So weather and climate is two different things. Long term average weather condition is known as climate, and the significant shift in the climate is known as the climate change. So what we are doing in a paleoclimatology. A paleoclimatology is a branch where we are studying about some climatic changes in the past. By studying or by reconstructing the data of the past, so it is very important to know the means how much data we are covered by our instrumental data, and which data we have to reconstruct by the some of the archive, or what we can say the different kind of phenomena, or what we can say the different kind of archive like lakes and ocean and all. So prior to instrumental record, so how much instrument record we have? We have mostly the records of the rainfall and all, that historical record and all. It's mostly from 1850 onwards. So before the 1850, we don't have any instrumental record. So that's why the paleoclimatology is very much important to know the past climatic condition, that how the data has been, how the climate has been behaving during the last 1,000 years, last 2,000 years. And so that's what how we can set the trend for the climate of the future. So that is the basics of the paleoclimatology and climatic terms. Now, India, when we are talking about India, India is basically receive the rainfall from the monsoon. So what is the monsoon? Monsoon is nothing but the reversal wind, a rainfall that is accomplished by the reversing the wind. So that is our monsoon. In Indian context, we mostly receive the rainfall from the monsoon. So India is receive the rainfall mostly from the three major systems. That is the southwest monsoon, which mostly contribute more than 80% of the rainfall in the Indian region. Then we have some of the South Indian state or South Indian part which receive the rainfall by the northeast monsoon. Then some of the part of the north part or northwestern Himalaya and all, we have a westerly influence. That is the three major system where the most of the rainfall of the India is received from these three system. So that is the present scenario where we are getting the rainfall from different rainfall system. So what is the present climatic scenario? Now we are talking about the present, past, and future. So now it's very important to know that what is the present climatic scenario. So is it the climate change is reality or myth? You may say that no, it's how. What is this question? That climate change is obvious that we are now experiencing what the lots of climate change. We have a different data, but before the I think 20 year or 15 to 20 year, the term climate change has been used, and some people are saying that it's not the climate change is not real, it's a myth, or it's what we can say the wrongly, the data has been put wrongly, or it's only a natural cycle and all. So in the present scenario, there is a debate over climate change in 2006, and that I already explained you that there is a major debate over the climate, whether the climate change is reality or myth, or whether it is a natural cycle. So this is some of the graph, some of the maps which I shown here, that how many people this is some of the graphs, survey-based graph from the US, that what is the opinion of different people about the climate change? Is it the climate change is real, or global warming is real or not? So you can see that there is some number of people still thinking about that the climate change is not real, it's a myth and all. But now what we need to do to prove that climate change is real, or it's whatever whether it is naturally, or it's what we can say the uh, it's a reality or myth. So we need some temperature data, or we need some data to prove that things. So there is a multiple lines of evidences to prove the things. So we have a different kind of paleo temperature records and other temperature indicator that can prove that is yes, the what we can say the climate change is not a myth, it's a reality. And if we are not planning, or if we are not what we can say the do the strategic planning for this climate change, we will fall short for this whatever the consequences for this climate change. So you can see that in the recent time the climate change one of the serious concern globally. So what the line of evidences we have, we can have the temperature record of the world from the different agencies. So you can see here in this graph from 1880s to 2020, you can have a shift in the temperature. You can see the anomaly, a world agreement of temperature are rising. This graphs is from the different agencies of the world. So it's from the National Climatic Data Center, and you have a Japanese meteorological agency. So all the agencies of the world who is monitoring the data, all the agencies of the world who is monitoring the data, they all reported that from the 1950 onward the temperature has been changing constantly, and it's in an increasing trend. So we also correlated these things with the industrial revolution around the 1940, the US industrial revolution and all, that temperature is having certain role to play, that with the industrial revolution the carbon footprint and the higher number of emission of carbon can also affect on the temperature rising. So nowadays you can if you are going to the NOAA website, you can constantly seeing that every month having the set the new record. Like when I was searching for the NOAA website during the 2019 and all, that April 2019 was the second hottest on the record for the globe. So then I also observed that one of the 2018 fourth warmest year in continue warming trend, means the whatever the scenario or whatever the recent the years or month in the recent past, they all are setting the new trend or new records. Means there is a constantly changing in a temperature or changing in a climatic pattern from the last few years or from the last few decades. So that also give us the glimpse that yes, climate has been behaving abruptly, and it may be having a significant changes in the pattern. So you can see that in a when we are talking about the climate, it having some significant spatio-temporal variation. Now you all know that, or you all familiar with that Kedarnath disaster in 2013, where we lost thousands of lives there in 2013 due to the GLOF or the lake outburst. At the same year, you can have the some drought in central India, in the Maharashtra and what. So that is the spatial temporal variation, that at the one end you have a flood, you have a heavy rainfall in that particular area or particular time. At the same time, you have the a drought in your one of the part of the your continent, Indian subcontinent, that is the central India. You have a drought season in the same time. So this type of spatio-temporal variability in the monsoon gives the us motivated to study this pattern. Was this pattern is continuously from the last several thousands of years, or this is just because of the human interference into the climate. So this all the scenario, this spatio-temporal variability in the monsoon gives us the challenge to study those things in the past. So now we have some evidences for climatic changes and global warming. So you can see this some of the satellite image and the role of remote sensing and GIS in this nowadays in a glacial study, whether the glacial is retreating or advancing. The role of GIS and remote sensing has been huge in the glacial, specifically the glacial study where we don't have access because of the some of the logistic barrier or some other things. So you can have a best to study this glacier and all by the remote sensing and satellite data. So you can see this two things like from 1956 to 2007, there is a two images. One image you can see that there is a more snow or you don't have that much of melted water there, whereas in 2007 you can have a more melting there. So it hence it prove that, or you can easily interpret with the some more line of evidences that there is a melting in that particular glacier with the study of moraine and all. So this is some of the evidences for climate change in that particular time frame. Also, we have some sea level changes in the last century. So this is some of the records for the sea level changes, how the sea level has been rise since the 1880s and onward, whatever the record we have. So sea level across the globe have rise about 8 to 9 inches since 1880, with about a third of the coming in just the last 2.5 decades. The rising seas are mostly due to the combination of meltwater from glacier or ice sheet and seawater is expanding as it warms. So there is seawater is rising, and what is the reason behind the seawater is rising? The reason behind the seawater rise may be there is some other evidences also, but what the reason is reconstructed or finding by the scientists is the melting of the glacial water. So melting of the glacial water directly can relate it with the climatic changes. Once your climate change directly affected on your glacial, they are melted more frequently than whatever their cycle is there, normal cycle. So that also increase or rise the sea level 8 to 9 inches from the 1880s. So there is some selected significant climate anomalies and event. This is a event from the April 2020. You can, if you are going to see the website, NOAA website, you can see the line of more evidences about the climatic changes, that how the climate has been changes. So whatever the instrument record we have from the 18th century onward, on that scale, you have a different kind of line of evidences, like you have a Arctic sea ice is extinct from this part. Then you have several European countries had the top 10 warm April in the record. Then you have in the Asian side, you have much of the North Central Asia had a temperature departure that were plus 2.5 degrees Celsius or higher. So overall, this is Asia's third warmest April on the record. So you can have a different kind of evidences from all over the globes that suggest that yes, there is a changes in a weather pattern, there is a changes in a climate pattern. So now this all are on a instrumental based reports, or whatever the observation we have, that all are mostly on a instrumental based report. So this is a different kind of reports. The more 2019-20 was among the warmest year on the report. So this is a different reports we have for the climatic changes. Now the thing is that this is all are the instrumental records. These all are the instrument record we have. Now what is the need of having the paleoclimatic studies? So paleoclimatic study is neat because there is some non-human cause for the global changes also. Okay, it's not only that because of the industrial revolution and because of the things has been changed after the Anthropocene started. Yes, there is some changes in a climate before the this all the industrial and human interference in the climate also. So what kind of that what things has been causes these changes? The solar radiation, then you have some meteoritic impact in the past, distribution of continents and ocean, mountain building, volcanism. So this is some non-human causes of the global change. It's not good or it's not correct to every time what we can say the every time you can have changes in a climate due to the human interference. There is some non-human causes also interact with the system, and it can also changes in the climate. So this is the some of the non-human cause for the climatic changes. So the mostly the one of the primary things which source of the energy is the earth, and that can regulate the earth climatic system. So sun drive the everything, but that does not mean that sun is causing our current warming. So this is a question to answer about that, whether the all the changes in the present climatic system is by the solar activity or by the whatever the sun is driving this climatic scenario, whether it is from the what we can say the this natural or from the anthropology. So this is the question to answer by these studies. So there is a misconception that recent warming is due to the change in the sun energy rather than the greenhouse emission. So recent data clearly show that sun irradiance is not correlated with the earth temperature. So we have some data for the solar irradiance uh, by the what we can say the earlier report. Some of the earlier reports suggest that there is a changes in the solar irradiances can also enhance the temperature. But in the present scenario, if you are seeing these graphs, this graph is till 1960 can be correlated very well. Okay, till the 1960 it can be correlated very well. But after the 1960, you can see that there is a changes in the graph. That one graph is going upward, one graph is going to the another way. So the trend you can easily see the trend between these two graphs, which clearly suggests that some of the last decade the changes in the climate has been also driven by the human. So this is some of the different climatic factor, or this is different climatic anomalies record from the different source. So when you are going to compare this different component with the present temperature anomalies or present temperature record, you can see that the anthropogenic component, is best matches with the temperature changes. So in the last few decades, it's now clearly we can see that human interference or anthropogenic activity has been more role has been increased. The role of the human has been increased or contributed more toward these climatic changes. So it's one of the fact that human activities emit 60 times or more the amount of carbon dioxide released by the volcano each year. So when we are talking about the natural versus anthropogenic, so this is a scale, or this is some of the stats which we can see that how many carbon or how many the greenhouse gases we are emitting as compared to the natural things. The volcano is also emitted some of the gases which impact on your cycle or climate. But when we are comparing this with the anthropogenic impact, you can see the how much means what is the comparison between these two? We have a 60 times more carbon dioxide released by us. So it's very much important to understand the past, to understand means it's very much important to understand the past to know the trend of the future scenario. Okay, so now from the last 2 to 3 years, we are very much experiencing about the COVID wave, COVID 1, 2, 3, and 4. So it's now we know that what is the behavior of the corona, how to treat that corona and all. So you can all the experience that in a first wave we don't know about the corona and how to fight with that corona means COVID things and all. So that abruptly come to all us, and we lost many of the lives, and still now we are going with the same things. So climate change is also having some significant shift in the system and all. So which am I audible? Hello?
Yes, yes, yes. You're audible. You're
Light.
audible.
Yes, yes.
You're audible. You're
Yes,
audible.
sir. Yes, yes, sir. Just shift in light, just a minute. Okay. So now the COVID has been already teaches us that you must be prepare yourself for whatever the things has been come to you. Like we have some vaccine and all. So like that, in future maybe we experience a thing like climate change or a disastrous thing like something maybe from the glacier, maybe from hurricanes and whatever the different types of climatic hazards changes. So this is a small picture. This is a small picture which what it suggested or what you I want to explain from this big picture is that if the road is tilted, it's better if you know that road is tilted. If you are going by your car, you can go with that one. But if the road is straight and if you have a sudden means you can have this sudden accidental things in front of you. If you don't know that this is a things in front of you, it's disastrous for you. So like that, in a climatic changes or climate studies, if you know that the trend is like that, you can still have a chance to correct your mistake or having a strategy for the to study this or to have a reduce the impact of climate change. So that's why the knowing the trend for the climate change is very much important. So can such climate changes magnitude can be predicted in advance? This is a question. Can the response of the earth system to system its environment parameter be quantified? Can this information be used for the future planning of the water resources and food security under changing climatic conditions with extreme climatic exertion embedded in it? So yes, we can miss not the error should be there or the precision and accuracy may be differ, but you can predict the climatic changes in advance if you have some climatic records of the past on a good scale on with the different from the different location. So whatever the record we have, so we can see this different kind of graphs I will show here. So if you see in this graph, you can clearly see that this is a cyclicity. Okay, this is a cyclicity between the this is a global temperature record from the last 3 million years. So this is a means from the last 3 million years we have a different climatic record from the different places. So this is one of the example. Just this is just one of the example. So if you can see that this is a cyclicity in the climate. This is a cyclicity in the climate. So if you know that we are in this mode, you can have after the several years. So this is a very the record is on a very longer time scale. But if you know that this cyclicity will be in the past and maybe in the futuristic trend also, you can have a shift between the cold climate and warm climate. If you know this cyclicity and if you know this trend, you can easily predict the futuristic trend and you can also easily plan accordingly. So knowing the this kind of things is very much important for the climate. So whatever the record we have on the based on the instrumental record, okay, the rainfall station and all the record we have. So different kind of records we have having some inferences. What kind of inferences we are taking from that instrumental record? That there is a lack of uniform trend but increase in a spatial variability in observed Indian rainfall extremes. Means there is a no uniform trend in the temperature, whether it is an increasing trend or from the or it is in a decreasing trend. But yes, there is a spatial variability has been changes, like what the example I have shown there, like Kedarnath, and the same year you have a drought in the central Indian scenario. So this kind of variability is increasing day by day. That what the instrumental record shows to us. Increasing trend of extreme rain event over the India. So this is a based on the several study which is carried out by the researcher, and giving the just a glimpse of that study what the instrumental reports suggest us. So increase the trend of extreme rain event over India in a warming environment. So based on the this instrument record, what the other inference we have that the trend of the extreme rain event, okay, like flood like condition. You also observe that flood like condition, floods have has been constantly increased day by day. The flood has been increased day by day. If you are going to for a statistic, the last decade, this decade, or you can compare this data with 2000 to 2010, 10 to 20, 90 to 2000. So you can have a more frequent flood nowadays. Then you have the other inference that observe changes in extreme and wet dry space during the South Asian summer monsoon. So this is different kind of evidences or inferences based on the instrument record we have. So now with the present climatic scenario, with the present weather system, we already has been no different kind of climatic parameter that can be used for the monsoon rainfall prediction. We already have been suggested that this year the monsoon may be surplus or may be deficient by this thing. So what kind of parameter has been used for this rainfall prediction? And how we can interpret those monsoon, that this year monsoon should be 5% more or 10% more, or it may be deficient. So the this is a 10 parameter we are using to predict the monsoon rainfall prediction, monsoon system like El Nino, Eurasian snow cover. So this all for the climatologist, it's very much important to know that whether this 10 or whether this only the 10 parameter has been affected the monsoon system, or we have some different system, like before the 2000 and before the 2000 we don't know about the ocean dipole system and all, okay, Indian Ocean dipole and all. So IOD phenomena and El Nino is also we have, means we don't know about that. El Nino is having you have a La Nina, then you have a dipole system. So this all the system has been studied by the researcher, studies their trend, their impact on the climate. Then they introduce this parameter for the monsoon rainfall prediction. So climatologist or the researcher may studies a different trend or different spatial distribution of the temperature, spatial distribution of the rainfall in the different region, and can also invent a new parameter or giving the new system that also that this is also affect or having the effect on the monsoon system. So nowadays we have lots of data in now we study from the last 14 and 15 days that the remote sensing and GIS give us the lots of data sets. Like we don't have to go to that place to collect the data by yourself. So you can have this data set, you can have the spatial analysis tool. So if you are compare this all these things to each other, and you can correlate this with the if this is the system or this is the temperature for the XYZ place of the Australian and all this one, and this having the impact on our Indian monsoon system. So anyone or if you going to study by this way, you can have a new system or new parameter can be introduced in that one. So this is the existing parameter or existing model we are using to predict the rainfall system. So now the third thing I talk about, whatever I talk about, that all are the present climatic scenario. Now I am going to talk about the paleoclimate, past climate or paleoclimate, how the past climate has been reconstructed. So paleoclimate is been studied by the archive. Archive is known as the material or thing that preserve the evidences of past changes in the climate. They contain the substances or feature of climate proxies that can be sampled or analyzed using the variety of physical and chemical model. So archive is nothing but the what we can say the natural laboratory of the climatic changes. If there is a climatic changes in before the 10,000 or before the 5,000 year, we don't have a anyone to say that yes, this is the temperature, or we don't have a historical record or written record that suggests that yes, the temperature for the what we can say the 5,000 BC is 48 degrees Celsius or 50 degrees Celsius. So we don't have this kind of evidences of the for the past thousands of year records. So we only what the record we have already told that the record we have was mostly the 200-year record we have. The more than that we don't have that much record for the climate. So archive and proxies has been used. The archive and proxy has been used to study those climatic parameter or climatic changes. So archive is nothing but a natural laboratory for the whatever the climatic changes. That archive may be a lakes, ocean, and variety of the other archives also there. So whether the climatic proxies are nothing but a physical, chemical, and biological material which provide you the geological record, and that can be analyzed or correlated with the climate or environmental parameter in the modern world. So this is the different kind of climatic archive we have that store that climatic records. The example for this climatic archive is lake. You can have ice core, then you have cave records, then tree ring and all. All these things has been capture the signature of climatic changes and store in it. So the undisturbed climatic archive, which very much important to know the past climate of the 10,000 year or whatever the that from the whatever the age of that particular archive. So you have this kind of archive in your. So what kind of proxies we have? We have a sedimentary proxy, biotic proxy, geochemical proxy. So this is some of the geological terms. Sedimentary proxy is a type of sedimentary rocks that indicating for a certain climate. So every grain is showing some of the significant, like sedimentary rock is nothing but it's formed by the sedimentary process. Like when some of the rocks or something has been broken down from the one place, and uh, it can be transport by the some of the geological activity from one place to another place and get deposited. So it capture the signature in between their source to destination, and there are other things like their how much rounded or whatever the other kind of signature is shown by that particular sediment used for the particular climatic, what we can say, the paleoclimatic observation. Then we have a biotic proxies, like you may heard about the term fossil. So fossil is nothing but the your record of the dead organism that is preserved in a rock. So that is your fossil, which also give us the evidences about that what kind of climate at that present time. Like giving you the example for biotic proxies, like we have now in Indian subcontinent, you can see the different state is having a different kind of animal. Like if you are going into the glacier and polar region, you can have polar bear and all. You can go to the central side, you can have different structure of animals, and in a tropical forest you have a different kind of system. So likewise, the biotic proxies giving you the exact because they are the one who originate and can live according to and absorb the climatic condition of that particular area. So it is the biotic proxies are the best one to give you the what kind of changes has been occurred in that particular area or period. Then you have a geochemical proxy. So what is the geochemical proxy? Geochemical proxy is nothing but the chemical reports, or when we are going to study the rock or the geochemical part or geochemistry of that part, the chemical behavior or the some isotopic study we are also doing for the same. So this kind of things has been regulated by the climatic changes of that particular time of the for the particular place. So this kind of proxies we are using, this kind of proxy we are using for the past studies. So this is a different kind of archive and different kind of proxies we are used for the paleoclimatic studies. So now once you have a proxy, means you have a record or the laboratory for that particular climatic changes, which record whatever the changes in your climatic system. Now you know you should know about that. Once I know that yes, this proxy or these things is showing that temperature is rising at that particular place, but when? Okay, the question should be there, that when this all these things has been happened. So for that purpose, you need a certain chronological things or chronological control, or you need some of the specific technique to know the age of that particular particular things. So what kind of chronology or what kind of methodology we are adopted to know the age of that particular archive or age of that particular things? We have a different kind of um, technique which we used. Like we have a radiocarbon dating. Maybe you all of mostly heard about a radiocarbon dating, because this one is a frequently used, and the different technique we have. So each and every one technique is having some significant contribution, because like that the radiocarbon dating is mostly used for the recent material or recent things. So the recent in geological terms, the 10,000, 50,000 year is we called as the recent things. So for the recent things, we use the radiocarbon dating. Then some where it's need a carbon basically for to doing the radiocarbon dating. You need a wood, charcoal, pollens. So radiocarbon dating has been carried out on those things only which having some of the carbon, maybe 0.1 milligram and something. The technique is nowadays is so much advanced that if you are giving some of the 0.1 gram carbon to the laboratory, they can give you the age of that particular things. Like in a plus minus, they have some like we can have precision and accuracy is a part of the particular lab and particular sample, but mostly you have a 30 to 40 or 40 to 50 year plus minus in that particular age, but you can have the age like these things has been deposited 5,000 year ago. So you can predict, or you can see the say that this whatever the climatic changes associated with that particular archive is happened before 5,000 years. So this is how you can use the radiocarbon dating for the paleoclimatic study. Then you have a luminance dating, and the other dating. So each and every dating is having some significant, like some of the dating is useful for the geological material which is older than the billion year or million year. That is the different, they are used a different, what we can say, the material and different things to date that particular thing. Some radiocarbon dating is using carbon, then uranium, thorium dating is also which use the uranium, and also different according to your sample you can use the different chronology for the different analysis. So this is the what this is not a what we can say the template, or this is not a thing. This is the methodology we generally use for the paleoclimatic studies. You can have to this is a methodology I have used during my PhD. So field work, then I am chosen a lake, that Renuka lake, one of the lake in Himachal Pradesh, where we are taking the core from the 8-meter core from that lake, and having a multi-proxy analysis on the part of the core which we have been taken from that particular lake. So what kind of analysis we have? We have the grain size analysis, geochemistry analysis, TOC, what kind of how much of the carbon is there present in that particular place, environmental magnetism, diatoms, then different kind of clay mineralogy. So each and every proxy used here is been analyzed by different instrument. The instrumental part is there. Then for the chronology, I already said that with whatever the analysis we are doing on that particular material, you should know about that what is the age of that particular thing. So for that I have used the radiocarbon dating during for that one. I have analyzed my sample in New Delhi IUAC, that is the Inter University Accelerator Center, where they provide the whatever the analysis you want to do, you have to present your work there. They can provide you the time that during this, from this time to this time, you can analyze your sample on a free of cost. So that is the beauty of that center, which is I think regulated by UGC. You have to just show that your research or your study is very much important. Giving you the they are giving the slot for the presentation, and they are specifically more means oriented toward the student, that students should not pay means their fellowship for this analytical part and all. So one radiocarbon dating sample has been if you want to date one radiocarbon, if you want to do a one radiocarbon dating, it costs around 25,000. But if you are doing in that particular center, that IUGS, you can have all this analysis free of cost. So this is one of the information I want to pass to all of you. So this is a methodology which I adopt for the analysis of the different terms or different proxy. Like this is a diatom proxy which I used. This is a magnetism. All this study has been carried out in Wad Institute of Himalayan Geology, where I did my PhD. This is some of the instrument which I have been used there. This is a X-ray diffractometer, XRD technique, which I used there. Then this technique is very much useful to know the mineral composition, that what kind of mineral is there, like what kind of clay mineral is there, or what kind of different mineral depending upon their 2 theta value. We basically do the or the whatever the sample we are taken out from the field, that analyze and after that it can be interpreted for a different purpose. Then X-ray fluorescence can use for the geochemical part, what kind of different oxide, different element is used. I have also done the radiocarbon AMS dating at IUGS. This is some of the picture. Then stable isotope. So this is a different kind of analysis I have done during my PhD. And if anyone want to know about the procedure and interpretation part for this all this technique, I am very much happy to help you. If anyone is from this means doing this kind of study, I am very much happy to help you out in this regard. If anyone is having problem with the XRD peak, the interpretation of XRD peak or grain size analysis and all. So this is the what the methodology I have been adopted. So depending upon the from the result, so we have a Holocene period, which is now divided into 3 different parts. Earlier, we called a Holocene only. Now we have 3 different subcategory of Holocene, like from 11,700 to 8,200 year. BP stand for before present. Then 8,200 to 4,200 and 4,200 to present. So this is a different kind of subcategory of the Holocene. Now we are living in a Holocene, and that is a subcategory or a revised what kind of revised time scale for the Holocene. So it is very good that the Meghalayan part of Indian, the climatic study which is carried out in the Meghalaya, and they are getting the signature that about the 4,200 year, there is a major climatic shift in the part Indian subcontinent and the part, and they have been taken this as a Meghalayan age. So now it's very good that till now we don't have that same period. The Meghalayan period is representing the Indian part. So this is the Holocene Paleoclimatic record of the different part of the world. Like Holocene, I already explained that it's from the 11,700 to present. So I have did some of the spectral analysis. One of the software that is a past, which is freely available. In that past software, you can do the spectral analysis that what kind of periodicity is there in your record. So periodicity in the climate has been great importance over other parameters. This allows the drawing the reoccurrence interval of the flood or drought. So if you also have some of the records of drought, flood, or whatever the changes in the climate, you can easily predict that if there is a certain cyclicity which repeat after every 1 cycle, 2 cycle and all. If you can do the spectral analysis in the past software, you can know that yes, this is a periodicity, and it cannot be you can plan better for this whatever the flood or whatever the climatic hazard you can have in that spectral analysis. So this is a result of spectral analysis. This is a result of the spectral analysis. So I have observed the 3 different cyclicity in my result, and among these 3, the 2 cyclicities already been reported, and this one is matches with the different reports which already reported from the several part of the world. That 129 year cyclicity, that is a historical observation data of the some of the solar. It is related to the solar, that solar irridances. This cyclicity is means my data is mostly correlated with the what we can say the solar irridance data. So that also suggested that the control for that particular area is the control of the solar irritances is more for the climate or regulate the climate for that particular area. So now I already suggest till now I discuss about what is the present scenario and how we can reconstructed the past using the different kind of analysis or different kind of methodology. Now for the future scenario or future prediction, every component of the earth has been affected by the climate. The ecosystem, water availability, carbon cycling or other things can be respond to the changes in the climate. So paleoclimatic parameter is provide a very essential perspective for the assessing the potential impact of the future climate on a natural system and the people who rely on them. So the future climatic changes also been the different group of the people or researcher. There is a we can say the three different group of the researcher. One is working on an instrumental part. One part of the or one group of the people is working on the paleoclimatic studies, and one group of the people is taking this past and present climatic records, and they run some of the models and knowing the trend, how the trend for the next 25 year or next 100 year. So the role of all these three groups is very much important as far as the climatic study is there. So we know that IPCC is a intergovernmental panel on climate change, is regularly monitoring all the data set, and they updated their all the models. The models which they are giving for the next 25 means 2100, the according to a new model, Australian warming could crack more than 7 degrees Celsius by 2100 under the scenario where greenhouse gas emission means they are giving the trend according to the present condition, and they are just taking this mathematical calculation that if the same rate or if you are going by the same rate, what may be the condition. So that's why the present as well as the past scenario or past climate is very much important for all this study. So this is what my all means glimpse of the presentation, that how the past conditions are there, what the instrumental record is there, and how where we are going for the next 100 or 50 years. So this is how we can have the different impact of the this climatic changes for the future projection, that more the drought and heat wave. We already observed this number of droughts, number of heat waves, or whatever the hazard and natural calamities increase day by day. So this is all from my side. Thank you very much, the organizer, for giving this opportunity to present some of the some of my work of my PhD and some things in front of all participants. Thank you all participants for listening this. If you have any question, you can ask.
Thank you, sir. It was a very good presentation, and we got to learn quite a lot from your research that you have gone through. And with this, I would like to ask, like, any of your participants, any questions you have, you can ask queries. Anyone of you have any questions? Okay. So let's move forward with the next presenter, Dr. Varunarayan Mishra. He is also going to present about his presentation. Sir, I invite you to present.
Okay, thank you, Priyanka. So first I'm going to share my slide. Okay, wait for a minute. I hope my screen is visible to all of you.
Yes, sir.
Is it visible?
Yes, sir.
Okay. So a very good afternoon to all of you. Myself, Dr. Varun, and today I'm going to discuss about the use of geospatial technology in urban growth analysis and simulation. Okay, as we know that you can say in most of the part of the world there is a high rate of urbanization. Urban growth is there. So how this geospatial technology can be useful for urban growth analysis, as well as how we can simulate the growth pattern for the future scenario, or so that we can predict the future scenario of the urbanization, or we can predict the future urban areas for better management and for better sustainable management of the urban area and natural resources. Okay. So before starting the topic about the simulation, I am going to discuss about some basic, or you can say the global trends in urbanization. So it was observed that up to 1960, there was only 34% of the urban population, but it is expected to have 54% of the total population, especially urban population. And it was expected to be, you can say 66% of the total urban population as per the United Nations report. Okay, so we see that there is a rapid change in the urban pattern, there is a rapid change in the urban areas, and in this graph whatever I have shown here, you see there is a different trend of the change in the urban areas and rural areas. The rural areas are almost having the flat pattern. It is not having the decrement or increment, but you see when you see the trend of the urbanization, so there is a rapid urbanization starting from after 1960s. There is a rapid urbanization growth around the world or at a global level. Okay, so there is a problem. There is a problem of urbanization. Urbanization is very fast. And when we compare the absolute urban growth between developing countries and developed countries, as India is under the developing countries, so you see the developed countries are not having very much high rate of urbanization. But when we see the developing countries in which India is also there, so you see there is a rapid urbanization pattern, and it is a problem for the developing countries, because most of the developing countries in the world are facing the problem of a very limited space for their people. They are having problem in the food, they are having problem in the water. Okay, so that all the problems related to the food and water and the clean air is because of the rapid urbanization in the developing countries. Okay, so this is another statistics which is showing the relative urban growth in a different part of the world. Okay, there are different continents in the world, and when we compare the relative urban growth among different part of the world, so you see most of the African and Asian countries are having the high urbanization or high urban growth pattern in comparison to other countries. And when we compare the urbanization growth or urban growth pattern at a world level, so you see it is expected to be around 60% of the total urban population. Okay, so this graph is showing the statistics between three different time intervals, starting from 1950, then year 2000 and 2030. So in most of the part of the world, you see they are having the problem of urban growth. There is a rapid urbanization, and because of this rapid urbanization, there may be different problems that causes the problem in the water, that causes a problem for food and for clean air, and there may be the problem for the population pollution and rapid population growth. Okay, so these three regions are there for the rapid urbanization. When we talk about the urbanization or urban growth, so because of the population growth, there is a urbanization. Because of the economic activities, most of the persons are looking for better economic activities, for better economic condition. They are moving to the urban areas from the rural areas for better future, for economic growth and health facilities, for education. And third is the increased urbanization rate, means the rate of the urbanization is very fast. In previous years, most of the part of the world are get urbanized. So these three regions are responsible for the fast urbanization. When we talk about the population is obviously growing around the world. So if the people is increasing, the number of population or number of urban dwellers are increasing, so they need some more space to live in. So they need some urban areas. That is also a major problem for the urbanization. Then economic activities and urbanization rate is also very fast. There is a very large difference between the you can say the urban areas and rural areas. Okay, but now most of you have heard two words: urban sprawl and urban growth. Okay, so these two terms are very much similar, but there is a slight difference between urban sprawl and urban growth. So the pattern, what kind of pattern is there? What is the density, and at what rate there is a built-up land is increasing? That raises a debate between two terms, that is urban sprawl and urban growth. Okay, so as a planning term, when we talk about the urban sprawl and urban growth, both are having slight differences. Both are having slight different definition. Both looks almost similar, but there is a slight difference. Okay, so urban sprawl is a type of urban growth. When we talk about the urban sprawl, so it can be considered as a type of urban growth. So urban growth can be considered as a broader category, and urban sprawl is a type of the pattern. At what pattern there is a urbanization and what is the density of the urbanization, that is known as urban sprawl. So sprawl is dependent on the way in which there is a development occurs. If there is urbanization, if urbanization is going on in any area, and what is the pattern, what is the density of that urbanization, that is known as urban sprawl. Okay, so most of the cities around the world, they experience growth. There is a rapid urbanization growth. Either they are having physical urbanization growth or having some growth in the population, or maybe there are the population growth because of the physical as well as the population. So urban sprawl is much more complicated, because sometimes urban sprawl may be considered as urban growth or not. Okay, so how a city is growing, what is the pattern of the growth of a city, it appears as a term that is known as urban sprawl. It may be considered as urban growth or not. Urban sprawl may be considered as urban growth, or it may not be considered as urban growth, because different cities around the world are having different pattern of the urbanization. They are having different density, they are having different population type, population density. So there may be different types of sprawl pattern around the world in different cities, different urban areas around the world. Okay, so without urban growth, there would not be the appearance of the urban sprawl. For urban growth, there should be some kind of urban sprawl, and that urban sprawl is a kind of pattern. You can say it's a type of the population, type of the cultural activities, type of different economic activities, what kind of density is there, how much you can say the different persons living there, what is their literacy rate, what is their economic condition. All these terms comes to a fact that rises the urban sprawl. So urban sprawl is considered as a type of urban growth that depends on a specific city, that depends on specific areas. Okay, so as we have already discussed, there is a rapid urbanization, there is a rapid urban sprawl. So because of that rapid sprawl in the urban areas around the world, there are having different negative impacts. So first and important impact of urban sprawl is on the environment. The environmental condition is degrading because of the urban sprawl. Because of this urban sprawl or rapid urbanization, the impervious surfaces are increasing. Okay, and due to this increment in the impervious surfaces, there is degrading water qualities. Water quality is degrading day by day because of this rapid urbanization, rapid urban sprawl. It is also responsible for the loss of wildlife habitat. Wildlife habitat is also get affected by the urban sprawl. There may be poor air quality because of the population growth or rapid urbanization. There are some industries and factories around the world, so they are emitting poisonous and hazardous gases. That is also causing the air quality. There are poor air quality because of this urban sprawl in different part of the world. Cities degrading, there are environmental degradation, there are also degradation in terms of some physical variables in a city, and also it is responsible for social degradation. Okay, So first impact of the urban sprawl is environmental degradation. Then it is also degrading the city quality, the life of the city, and also it is responsible for some kind of degradation in the social activities of a person. Okay. Second is a city degradation because of the urbanization, rapid urban sprawl. There is a problem of traffic. There may be the high traffic problems, and because of urban sprawl, the tax rates are getting increased. There is a loss of local business, and it is also responsible for intercity decay. Third impact of urban sprawl is on the social activities or social you can behavior of the person living in that area. Okay, so because of this rapid urbanization, there may be the decline in the economic opportunities. Some persons are getting very good money from different economic activities. Some persons are having not some persons are not able to have good economic condition. So instead of having urban sprawl, there may be the person that can be considered as a urban poor. Although they are living in the urban areas, but they are considered as a urban poor because there is a declining trend in the economic activities or economic opportunities. Most of the persons are not getting proper economic opportunities, so that they cannot have good economic condition. There may be the loss of the place and communities, and reduced access to the open spaces. Urban green spaces is very important for maintaining the ecology of that urban area. So because of this urban sprawl, there is a reduced access to the urban spaces, urban green spaces. You can say it urban green spaces. Urban green spaces are decreasing day by day because of this rapid urbanization. And also this urbanization pattern, right now most of the person are looking for better economic activities. They are busy in their schedule from morning to evening and for morning to night. They are not having much time to interact with each other. They are not having good interaction with their neighbors. So this rapid urbanization, most of the people are looking for good economic condition. They are making money, they are busy whole day, so they are not having much time to get interaction with the neighbors. They are not having good social interaction, although they are active on the social media virtually, but they are not having much time to interact face to face with the person. So this is another kind of impact of that urbanization. Okay, urbanization is also impacting the social behavior and social and cultural activities of different person, different residents of that urban area. Okay, so as we have already discussed that there are two terms, that is urban sprawl and urban growth. Okay, so but the sprawl term is not having any universal definition, because as we have already discussed that sprawl is a type of pattern of the urbanization. So different cities, different part of the world are having different pattern of the urbanization. So there may not be any universally accepted definition for the urban sprawl. So in most of the time, we should not consider the urban sprawl term for urbanization. Okay, for studying the urbanization, we should study the urban growth, not urban sprawl, because urban sprawl is site specific. Urban sprawl is a term that is specific to a particular region. Okay, and it is not necessary that any kind of urban growth is considered as a urban sprawl. Some kind of developmental activities can be considered as a urban sprawl, and it may not be considered as a urban sprawl. Okay, so the use of the term urban sprawl has a negative connotation, and it is considered that the urban growth is not necessarily unhealthy. Sometimes urban growth is very good. Sometimes urban growth is considered as a good for that urban area. So urban growth sometimes may not be considered as urban sprawl. And for studying the urban sprawl, we should study the pattern of the urbanization. We should study the density of the population. We should also study the impacts of different types of urbanization pattern in that area. Okay, so in some cases, the urban growth are actually remedies for the urban sprawl. Urban sprawl may be unsystematic. Urban sprawl may be, you can say, having some negative impacts, but urban growth is a kind of systematic urbanization, kind of systematic urban pattern of that area. So it may reduce the impacts, or the proper urban growth, proper urban planning may reduce the impacts of the urban sprawl on the environment as well as on the local public living in that area. Okay, so now I'm going to discuss about the urban planning. Urban planning is a kind of method or technique that is contributing the development of an area. Okay, and that is based on the economic activities, as well as there are different social activities, legal activities, aesthetic concepts are there. We should also focus on the aesthetic concepts, means we should focus on the infrastructural development for getting some aesthetic components, and there may be some other conditions that is very important to promote the welfare of the public and the quality of environment. So urban planning is not only the construction of the building. Urban planning is not only the construction of roads and different infrastructure. It should also promote the welfare of the public. It should also promote and conserve the quality of the environment. Okay, so it should be sustainable manner. Urban planning should be in the sustainable manner, and it should consider different types of the urbanization pattern, different types of the planning. So when we talk about the sustainable urban planning, so it's a comprehensive term. When we talk about sustainable urban planning, it's a comprehensive understanding of the use of different land use. How we are utilizing the available space in that area, how we are utilizing the available land in our area for better economic activities, for the development of different infrastructure and roads, buildings, and construction. So in order to prepare urban development plan, we should have the detailed information of the existing land use, land cover. We should have the detailed information about the distribution of different landscape in that area, so that we can go for the sustainable urban planning. Before going for any planning activities, first we should know the existing scenario of that area, and we should know how much area is left blank, how much area can be used for different activities, so we can go for the planning and management activities. Okay, so this is the way how we can go for the sustainable urban designing. Sustainable urban designing includes the components that is required for the open space. We should focus on the development of open space. We should also focus on the developmental of urban green spaces that will be used for different social activities, where people can go and can interact with each other, like the park, gardens, golf course. Okay, pathways, there should be pathway in urban areas. Landscape designing should be there. We should have proper structure, proper developmental structure in that area. Restoration of historical buildings. Urban planning or sustainable urban designing includes the restoration of historical buildings. We should also preserve the historical buildings. Then there may be requirement of energy. Okay, so we should focus on the macro energy generation, because without energy consumption, because of the unavailability of energy, there may be the problem for the persons who are living in that area. So sustainable or the sustainability also includes the availability of the energy. Okay, so for sustainable urban designing, we should focus on the generation of energy sources, different energy sources, but these energy sources should not impact the environment. It should have some kind of green energy. Now the term, most of the areas in the world now, the very recent and new term, that is green energy. So we should focus on the generation of the green energy without hampering the quality of the environment, without hampering the quality of that area. Okay, so and there are other kind of facilities that are required for the sustainable urban designing. We should also have the option for the allocation of the marketplaces. There should be the available spaces for the market. Okay, we should have the option for the allocation of hotels, that is rehabilitation centers. Okay, so sustainable urban designing, or when we go for the sustainable urban planning, so it requires a lot of efforts in different you can say the components. It should have different parts. The components that is required for the sustainable urban designing includes the open green space, there may be pathways, there may be historical buildings, okay, green energy, then there may be different types of architecture planning should be there. There may be some areas for the market and some hotels. There may be some rehabilitation centers that is required for the urban area. Okay, so now we are going to see, and we are going to see how this geospatial technology can be used for the urban growth analysis, urban growth simulation. So it is already discussed with all of you that geospatial technology is comprising different technologies, that is remote sensing, geographic information system, GNSS, that is global navigation satellite system. There are other emerging technologies like LiDAR and other advanced technologies, that UAVs are there. So different technologies combinedly known as the geospatial technology. And I'm not going in detail about these terms. You have heard, you have studied about these terms in the last 14-15 days of this winter school. So now I am going to discuss about how this Earth observation technology, that is normally known as remote sensing technology, it will be very much beneficial for the urban growth analysis and simulation practices, because most of the data sets that is required from the satellite data sets, they are having spatially registered. It's excellent data source for the covering the larger landscape area. Okay, and there is availability of temporal data sets. So when we are going for urban growth analysis, urban growth modeling or simulation, so there should be the requirement of the multi-temporal data sets. And these kind of multi-temporal data sets, or the data sets of the same area in different years, can be available from the Earth observation technologies. So Earth observation technology is very much useful for urban growth analysis and the simulation practices. Okay, so this is a framework how we can use remote sensing and GIS and emerging technologies of geospatial approach for the planning process. We should first determine the objective. What is our objective? Then we can go for the resource inventory. We should work and we should develop some kind of resources for fulfilling the objectives what we have defined for the planning of that area. Then analysis of the existing situation. Then we can go for the modeling and the projection of the future scenario. And after getting modeling and future scenario, we can develop the planning options. Then we can have, if we are having different options, so we have to select the optimal planning option among all the planning options available there. Then we can go for the implementation of that planning, and that can be further used for the sustainable urban development and sustainable urban planning, or the infrastructure development in that area. So this is a kind of process that includes the data sources from the remote sensing. GIS can be used for the visualization and analysis and integration of multiple data sources, different thematic layers. And there may be other data sources from different technologies can be used for the planning activities. So the entire planning process includes a lot of data source coming from different technologies, different geospatial technologies. Okay, so moving to the next slide. So this is very commonly used term, that is land use and land cover. Okay, so land use is the utilization of the land for some economic activities. Land cover is a natural surface, natural earth surface, like you can say the water and forest, different types of other natural surfaces are there. It is considered as a land cover. And land use is how we are utilizing the available space, how we are utilizing the land for better economic activities, for different infrastructural development. That includes the development of residential area, industrial area. We can construct flyovers, railway bridges, anything that is done by the human. That is basically the human activities. Okay, so when we talk about the urban growth, or when we are going to study the urban growth pattern, so eventually we are studying the land use, land cover of that area. Urban growth or urban area is a kind of land use in that area. So before going for the urban growth analysis and urban growth simulation, first we need to know what is the existing land use, land cover scenario of that area. Okay, and how this land use, land cover is changing, and how it is affecting the urban areas, how it is affecting the natural surface as well as the man-made or artificial surfaces. So land use, land cover change is one of the important component that is affecting the human life as well as the environment for in the era of urbanization and the rapid urban growth. Okay, so this is the way how we can study the dynamics of land use, land cover change. This is an example of an area which is showing the pattern of the land use land cover starting from 1974 to 2008. You can see there is a lot of changes occurred from 1974 to 2008. Okay, there are total 6 land use land cover categories. It is shown here, and that is having developed area, that is you can consider as a built up area, an urban area, and water bodies are there, forest area, bare land, the grassland, and agriculture. So you see there is a rapid urbanization pattern. The red patches, the red color is showing the developed areas or urban areas, and there may be some decrease or there may be some loss of natural surfaces. So before going for urban growth analysis, first we need to study the dynamics of various land use land cover categories in that area, and after analyzing the dynamics and pattern of land use land cover, we can study the pattern of the urbanization. We can study the areas that is converted from natural surface to the artificial surface or urban areas. Okay, so these are different factors that is affecting the land use land cover in that area. It is considered as a spatial factors, then spatio-temporal factors, and the temporal factors. When we talk about the spatial factors, so these are some kind of changes that remains relatively static with respect to the time. Okay, if it is having changes without affecting the time, that is spatial factors like digital elevation model and different other data sources. Spatio-temporal factors can changes over both in time and space. And temporal factors, these are kind of changes in that area that is spatially static for a given study area, like GDP. GDP is a temporal factor. It is not having any spatial factor or spatial dimension. So there are two types of factors, direct factors and indirect factors. The direct factors are affecting the changes in the land use land cover, and you may also consider some indirect factors like the GDP and the, you can say, different economic activities, different socio-economic data sources as an indirect factor that is affecting the land use land cover. Okay, so land use land cover changes. After studying the land use land cover changes, we should use different land change models. These land change models are a kind of tool that can support you to analyze the changes. It can also help you to analyze the causes and consequences of the changes in that landscape, in that land area. Okay, so the land change models, these are basically a kind of models that study the past trend of that urban area, and on the basis of the past urbanization trend, it can predict and simulate the future scenario. So these are very complex models. When we talk about the land change models, these are having different complex components. We should incorporate different variables, different factors that is affecting the change in that area. So it is not very easy to apply land change models for the urban growth simulation and analysis. You have to specify different variables, you have to define different factors which is responsible for the changes in that area. Okay, so this is all about the variables and factors, because different areas may have different factors that is responsible for the change. So first you need to identify the variables and the factors which is responsible for the urbanization, which is responsible for the rapid change in the urban areas, and also on the basis of the past trend, you can predict and you can simulate for the future year. Like on the basis of the past trend from the 1980 to 2020, you can predict and you can simulate the change for upcoming years for 2030, 2040, and for 2050. For any year, you can predict, you can simulate the changes on the basis of the past trend. Okay. So the land change model should be spatially explicit. Spatially explicit means it should support the spatial data sources. It should take use of the spatial data sources. It should be quantifiable. What type of changes are there? The land change models should be capable to quantify the changes in terms of some numbers. Okay, it should also examine the total landscape, not only the part of that urban area. Still, it should have the option to cover the larger area, total landscape. It should maintain the spatial pattern, and it should also be able to display the emergence of the growth over time. And sometimes we need to use the historical data sets. Sometimes we need to use the past data sets, past trend of the urbanization. So these land change models should be able to use the historical data sets. On that basis, we can predict for the future scenario. It should be intuitive, interpretable, easy to calculate, and it does not require much data input. So these are some of the basic characteristics of any land change model, or you can say the simulation models for the urbanization and for the urban growth analysis. Okay. So as we have already discussed, that drivers means the variables and the factors. If there is a change, if that urban area is having some kind of change, so what are the drivers that is causing the change? So these drivers are very important for this simulation. Okay, most of the land change models consider the changes as a function of the different socio-economic and the biophysical variables. For urbanization, there are different socio-economic variables, there are different biophysical variables who are considered as driving factors, who are considered as a main variables responsible for the change. So drivers is very important component of running any land change model. These driving forces considers different socio-economic factors as well as different biophysical factors, and that these socioeconomic and biophysical factors are a kind of drivers that is responsible for any change, that is responsible for the change in that area. Either the change is in the artificial surfaces like urban areas, either the change in the natural surfaces, or that is land cover. Okay, so these are different kinds of drivers. When we talk about the drivers, these drivers may have socioeconomic data sets like infrastructure extension, transportation, markets, the allocation of new markets, the development of new transportation facilities, the development of different types of settlements and industrial areas are there. It may be considered as a driver because of the infrastructure development, because of the development of industries. There may be the change in that area. Agriculture expansion may also be considered as a driver. There may be different other factors are there. Demographic factors may also be considered as a driver for the change in that area that will cause some natural increment. Migration is also very important driving factor. Most of the people moving from the rural areas to urban areas. So how much people are migrating from rural to urban areas? It is a kind of migrating pattern. So this migration is also responsible for urban growth and urbanization. Population density is very important. Then what is the distribution of the population in that area? What is the type of literacy rate is there? What is the age group who are living in that area? There are different economic factors are there. Okay, that includes the industrialization, how much area is industrialized and how much area is under construction. Okay, so these are different drivers. These drivers are very important for causing any change in that area, for causing the urban growth in a particular area. So it is dependent on this area. A driving force may not be qualify for the same area. Different urban areas may have different driving factors. So you need to first study the driving forces or driving factors so that you can really you can see what kind of driving factors who are responsible for the change in the urban area. So the land change modeling is having two components. When we talk about the land change modeling, it's a kind of statistical relationship between the variables and how these variables are causing the changes. So first we need to go for the identification of driving factors. These driving factors will give us the information about the land use demand and different types of analysis that includes the location of that driving factors. First, we need to identify the driving factors. It's a kind of non-spatial data sets that will tell you the information about the land use demand. Then what is the location and what is the position of that driving factor in that area that gives you the information about the land use allocation. Okay, this is the entire modeling framework. When we talk about the modeling, so modeling is not an easy task. Before going for any modeling practices, you should identify the driving factors, and these driving factors should be identified qualitatively and quantitatively. So first you need to identify the driving factors as a quantitative information, how much change is there in terms of change in the areas, in terms of change in different other temperature and other precipitation values are there, then how these driving factors is locating, means what is the location of the driving factors. If there is a change is going on there, but what is the location of that change? You should also know, you should also have the information about the location of that change. So modeling framework requires how much and where, how much change is happening there and where it is happening, what is the location of the change. That these two information, these two components are very important for running any model. Okay, so how much change is there, it provides you the information about the demand, how much area can be demanded for the future simulation, and what is the potential sites for the developmental activities. That comes from the driving factors and dependent on the location. Then after getting different variables, there may be multiple variables, there may be multiple demand variables, there may be multiple potential variables. After integrating all the variables, we can go for the modeling practices, and then we can simulate the scenario for the future area, future time, and then we can see the how much area has changed on the basis of the past information. Okay, so this is the way how we can go for the demand means how much area is changed between two different years. Okay, that will give us the past trend. In the past we need to know how much area has changed, and on the basis of this information we can predict, we can simulate the future scenario. Okay, potential sites means what is the potential, means potential sites means at what area there may be the high potentiality of the change. So for that we use neural network and different machine learning algorithms. These machine learning and neural network, generally we use the neural network algorithm for the identification of potential sites. These potential sites is dependent on the past trend, means if the area is having high tendency to be changed, then there may be the high potential for the change in the upcoming future. So the transition potential modeling is a kind of sub model of a change model, and it will tell us the information about the areas which is highly probable to be changed in the near future. That is a potential. So we should have demand, we should have potential. These two components are very important. Okay, these are some of the important simulation models that is used in the urbanization and urban growth pattern. That's a Markov chain. It is very famous, very well-known model for the simulation. Then cellular automata Markov chain and a multi-layer perceptron neural network model that will also work in collaboration with the Markov chain. So Markov chain is basically it is used to quantify the changes. Markov chain only tells us the quantitative information. It will help us to identify the changes, how much area is changed from one category to another category in that area. But it doesn't provide us the spatial information. It doesn't provide us the location. So for getting the locational information, for getting the areas, or you can say for getting the spatial distribution of changes, we integrate Markov chain with other machine learning models, that is cellular automata and the neural network. So Markov chain is still a kind of model that is used for the simulation, but it doesn't provide us the spatial distribution. It only provides us the quantitative information. It provides us the some kind of numbers, and on the basis of that number we can integrate it with the machine learning models, and we can go for the spatial distribution of the changes. This is a cellular automata, means when we integrate the Markov chain with the cellular automata, the cellular automata is a kind of you can say, in short, it is a kind of you can say the change means how this existing pixel is having the highly probability to be changed. So cellular automata is word that is having two terms, cell and automation. Cell means the pixel, and automation means how there is a possibility of the change of the pixel into another pixel, and the central pixel will be that is surrounded by the surrounding pixels. It is having high possibility to be changed in the surrounding pixels. If the pixel is having agricultural land, okay, if there is a pixel of agricultural land and it is surrounded by some urban areas, the pixel of some urban areas, so there is highly probability that that urban pixel or that agricultural pixel will be converted into the urban pixel. So this can be done on the basis of some process that is known as automation. Automation is a kind of simple transition rules. It can be considered as a process that determines how much pixel is surrounded by the nearby pixels, and what is the probability of the change of a central pixel that is surrounded by some nearby pixels. So it depends on the neighboring pixels. Okay, the neural network is very well known machine learning algorithm. It is based on the backpropagation algorithm. So if there is a change in the urban area, there is not only single change. If we are having total 5 or 6 categories in that urban area, so there will be multiple transitions among all the categories. So multi-layer perceptron neural network integrate multiple transitions into a single platform that will provide us the facility to you can say the model multiple transitions, so that we can get the output as a simulated result. Okay, so it can also have the option to facilitate to combine different transitions, different variable that is affecting the land use land cover transition. So this is a case study which I have done, and in the case study, I have used the multi-temporal data sets starting from 1988 to 2020, 2015 over the Varanasi district. And first we have classified the entire image into different classes. Total 7 classes have been identified. And after getting the information about the change in the areas, how much area has changed from one landscape category to another landscape category, first we need to study the aerial distribution, the distribution of the area of different land use land cover categories. Then we can study the changes on the basis of the amount of change from later year to the previous year. And then we have we have analyzed the gains and losses in different land use land cover categories. So this gain and loss is telling us, it is providing us the information about how much area is having gain and how much area is having loss. So which area, like this is the Varanasi district, which area is having gain, which area is having loss in terms of different landscape categories. So gain and loss for agriculture means where agriculture land is having loss, where agriculture land is having gain. And persistence means which the areas which is not having any loss or not having any gain. Okay, so when we talk about this gain and loss figure of built up area, you see the green patches is very high there. Green means there is a high gain of urban area, means one class is converted into the urban areas. So green patch means the gain in that area, and the yellow color is showing the persistence, means that area that is not having any kind of loss or gain. And red patch means there is a loss. So dense vegetation, there is a loss in the fallow land. You can see the red patches in the dense vegetation. Some fallow land areas are having some loss. But when we talk about the built up area, that is urban area that is having high gain, means that is kind of urbanization, or there may be some urban growth. Okay, this is the spatial trend of the change analysis, means which area is having highly spatial trend of the change. So the central area of the central portion of the study area is having dense in high intensity of the trend of the change. Okay, this red patch, the central pixel or the central area of that urban area, that study area is having high intensity of the change. And the spatial trend of the change analysis will tell us the information, means in what area or you can say in what direction there is a trend, whether it is changing in the west side or east side or north side or the west side. Okay, so to see the direction of the change or to see the direction of the urbanization in that area, you need to apply the spatial trend change analysis. Spatial trend of change analysis will tell us the pattern as well as the direction, in which direction there is a urbanization. Okay, then we have generated the suitability images. These suitability images are kind of pixels that is having high possibility to be changed into another class. Okay, so most of the areas is having high suitability to be changed into another class. So that suitability image is very important for the simulation. First, we need to identify which area is suitable for the change, which pixel is having high possibility to be changed into another class. So after getting such kind of suitability image, suitability information, we can simulate for the future scenario. Okay, so there is a some quantitative information. That transition area matrix is a kind of quantitative information, and transition probability matrix. These two quantitative tables, quantitative information can be acquired from the Markov chain model. Markov chain tells us what is the probability of the change of a particular class into another class. So you see in the table 4, different landscape categories is having different probabilities of changing from one class to another class. So different pairs, we have to compare the pair of different categories, and you see most of the cases the built up area is having highly possibility, that is 0.85, means 85% possibility is there that built up area will be converted into built up area. So this is showing how much transition probability is there, and uh, what is the chance of the conversion of a particular land use land cover category to another land use land cover category. That is very much useful for the simulation process. Okay, then we have to select different transitions and variables. So after getting the analysis, means how much area is changing from one class to another class, we have identified these important factors. These are the driving factors, means the change of the agricultural land to fallow land, agricultural land to built up land, then fallow land to agricultural land. You have to identify the variables, you have to identify the driving forces, which is the dominant driving forces that is causing the change in that area. So we have identified the total 9 major transition, 9 driving factors that is responsible for the change in that area. Then total 6 environmental variables have been considered, that is having elevation, slope, aspect, the distance from the major road, distance from the railway network, and also the distance from the existing built up area. These are some of the variables, and these are some of the factors that is used for the development of the model. On the basis of these variables and the factors, we have developed a model based on the Markov chain model as well as the neural network model, and these are some of the driving variables. So we have considered total 6 driving factors, or you can say these are the environmental variables, having digital elevation model, slope, aspect, distance from major road, distance from the rail network, distance from built up land. The empirical likelihood map is showing the highly possibility of a change in that area. Okay, these are the constraints. Roads and railway networks are considered as the constraints. These are the areas which cannot be converted from any class because it is already existing. We cannot construct any building on the road. We cannot construct any new infrastructure on over the railway network. So these are the constraints, means these areas are not affecting any kind of urbanization pattern. Okay, then after getting the past trend, we can have the transition probability for upcoming year, that is 2030. I have predicted for 2030 and 2050 on the basis of the future past trend, and these are some kind of the pattern, how much, means what is the simulated pattern, simulated change of that urban area, how much simulation is there. So first we need to simulate the land cover scenario for a year, and then we can compare it with the existing reference map, and we see the validity and you can say the accuracy of our simulation. For validating the accuracy of our simulation, we have to compare the simulated result with the existing reference image of that area. And after getting some good agreement in terms of 4 different variables, that is k no, k location, k location strata, k standard. These are the 4 variables, and you can say these are the kind of accuracy measures that is used to validate the result, that is used to validate the simulated map. Okay, then after comparing the simulated result with the reference image, we have predicted the urban areas, we have predicted the scenario for the future year for 2030 and 2050, and then we have also studied, we have also calculated the areas for different land use land cover categories for 2030 and 2050, and on that basis we have the information about which areas is having highly prone, which area is having high possibility to be converted into the urban area, which area is having high probability of converting from agricultural land to any other class. So this is the way how we can go for the simulation, and this is the way how we can analyze the urban growth, as well as using neural network and different Markov chain and cellular automata models. We can predict the future scenario. Okay, so thank you very much. And if anyone have any question, then you can ask. So this is all about the urban growth analysis and simulation using the geospatial technology, how we can use remote sensing data sets, how we can use different machine learning algorithms for the development of land change models and land simulation models. So if anyone have any questions, then you can ask. Otherwise, we are going to close the session right now, and we will meet again for the training session.
Sir, I have a question. If we want to simply make a land cover map for a small area like 5 square kilometer to check the development, like building of a university location for past 40 years. So how can we go for simple approach, and how the process I want to know?
Okay, if you are focusing on a specific building or this university campus, okay, so generally the Landsat data set is not having the resolution that can provide you the detailed information. So for like if you want to study or if you want to see the changes in the university campus, so for that you can go for the high resolution data sets. Okay, because it is not possible to get more details while we use Landsat images. So it can provide you the broader information about the urbanization. But if you want to target, if you want to specify a particular building or particular campus, so for that we need to use high resolution images from the Iconos and QuickBird sensors. लैंडसेट में इट इज नॉट पॉसिबल कि आप किसी एक पर्टिकुलर कैंपस को आप आइडेंटिफाई करके उसमें कितना चेंज हुआ देख सकते हैं, बट हाँ एक ओवरऑल व्यू दे सकता है. बट फॉर डिटेल्ड मैपिंग ऑफ अ पर्टिकुलर यूनिवर्सिटी कैंपस और एनी काइंड ऑफ अदर इंफ्रास्ट्रक्चर you need to go for the high resolution data sets that is having resolution less than 1 meter or 2 meters.
Thank you, sir. And how to do the classification, like how the changes have done in past?
For classification, as already discussed in previous lectures, that there are two ways to classify your satellite images: supervised and unsupervised classification methods. So as per your expertise, you can use any supervised classification method to classify the entire image into different landscape categories of 2 different time periods. Okay, you can use support vector machine or neural network, maximum likelihood. There are a lot of approaches, methods are available for the classification of the satellite images. After classifying the satellite images of 2 different years, calculate the area, and then you can analyze the changes. You can detect the changes in different landscape categories. So you can use any software for the classification process, classification purpose of the satellite images.
Sir, Saga we can use ना?
हाँ, yes, Saga में तो है. Saga में आप classification कर सकते हैं. QGIS is also having the facility for classification. There are other open source softwares are there. Okay, ADAS Imagine is a proprietary software. NV is there, but these are the proprietary softwares. So there are a lot of software, a lot of options are available. You can use any software for the classification of the satellite images, and you can have the statistics of different land cover categories. And after getting the statistics for 2 different years, you can analyze the change either in the urban area or agriculture land or any kind of landscape change.
Thank you, sir. Thank you.
Okay. Any other question from anyone? Okay, so now the first half of the winter school of 25th January is over now, and we will meet again for the training session for the hands-on practice of the software, open source software.
From 2:30, from 2:30 onwards, because we have got an extended section, so we'll start from 2:30.
Yeah. From 2:30 we will assemble again for the training session. So all of you just take your lunch, and we can...
tomorrow, because there is a Republic Day, so we will be trying to sum it up, because we have got to prepare something for all those Republic Day celebrations.
Yes, yes. Okay. So we will meet again at 2:30. All of you join at 2:30 for some
Bashir,
training session.
meet at 2:30. Bashir, 2:30.
Okay, sir. So we meet again 2:30. Okay.